Hey, what's going on, everybody? How you doing? Okay, what do we got? It's Thursday here. Thursday, what's going on? Still absolutely love the look of the car. Yeah, MR. It's MR and I were talking about the Coronet before work here. How's everybody doing today? Hope everybody's doing well. I got a Nightbot. We got to tone back Nightbot. Hold on. Man, I'm sorry. Nightbot's just belting people left and right. I gotta tone that thing down, man. Did the launch progress? Yeah, I think so. Yeah, I'm pretty sure. Pretty sure the sucker's up in space. Progress, what was it? Progress 93? Or no, Progress MS-32. Well, Progress 93 is the mission. MS-32 is the rocket. Or the capsule. It just launched to go into the ISS. It should get up there pretty soon. It launched out of 31.6 at Baikonur. Yeah, everything's good there. Yeah. Creation, don't. Don't even mention it, dude. I don't. Guys, I don't. Just don't. Let's
this is
talk
space.
about the car.
I'm in space.
Okay. So I did get, because whenever I try to go out and work on the Coronet, something goes wrong with the setup. So the reason why I didn't finish the stream yesterday is because I went and checked my UPS after I logged off stream. So actually, well, let me collect my thoughts here. So while I was doing the automotive stream yesterday, trying to just finalize panel alignment for the back of the car, both of the computers in the office in here, I mean, maybe the behind the scenes camera wants to work today, both of the computers blue screen at the same time. And the last thing I need is to undervolt like $4,000 computer that chat gave me. I don't want to be the one that breaks that, right? So we kind of isolated the problem, and we figured out that this computer and the encoding computer 5 monitor setup is basically pushing one uninterrupted power supply to the absolute limits. The uninterrupted power supply, I went back and looked at my bank statements to see when I bought it. I actually ended up buying it. I bought it in 2023, so it's not that old. The one that I have in there, it's not that old, dudes. It should be well within like battery life. The batteries in the UPSs usually last 3 to 5 years, right? Like, we're only at 2 with that one. So we were overdrawing power. And I went back and I looked at, I thought back to the other day when we were playing Stationeers, and between all the extra streams that I had up on all the monitors, all the extra windows, everything going on, I remember I looked at the load, the wattage on the UPS, and it was above 900. It was like 930 something. So we're basically just getting to the very end of usage, like the higher upper end of like overstressing that one power supply. The uninterrupted power supply can only pull so much wattage. It's 1500 volts, or 1500 VA, 900 watts. We were just pulling a little over 900 under load with both computers. So I did the right thing and bought 2 more 1500 VA 900 watt sine wave UPSs, and they're actually up there. You could just see the top of them up over the light. over there. I bought 2 of them, and it wasn't cheap, but I bought 2 of them because I don't want to break this setup at all. I want this setup to last, and I want it to last indefinitely. That might be a little bit overkill, but whatever. So how I have this thing currently set up right now is I have the UPS that's 2 years old plugged into power for pretty much all the auxiliary components: lights, monitors, mixer, amplifier, audio interface, and the auxiliary power strips that I use down here. You can see one of them. You can see one of them right there. And then the 2 sine wave UPSs are respectively plugged into each computer. Just them. That's way overkill. That should never be a problem ever again. Knock on wood. So, yeah. I didn't want to risk undervolting anything yesterday. I don't want to break something in this brand new computer. I don't want to break something in my encoding rig. I just got this set up more or less relatively stable, and I don't want to screw with it. So I kind of chose the nuclear option, but it should pay off later, you know, in never having a problem. It's not overkill if it's your livelihood. Bingo. Do we have Nightbot commands yet? No. Is the garage PC on a UPS? Yeah, I just replaced it when Ernok was here. Brand new. It's not as beefy as the ones in here, but yeah. So now we have 3 UPSs on the table back there. And yeah, I was doing load tests. That's why I missed the progress launch that just happened. I had games up on all the computers and everything. I had games up on all the computers, or the 2 computers, OBS looking for NDI from the garage, etc., etc. And I was just doing a couple of load tests there, and yeah, I just wanted to be absolutely sure. And while I was doing load tests, I remembered that progress was going on. Oops. It was a resupply. It's an ISS resupply. It's no big deal. But anyway. It's infrastructure, pricey, but not worth skimping on. Yeah. Yep. So, is shutdown automated yet? USB cable connected? What do you mean, Martin? Good call. During power failures, you have monitors, lights, and time to manually shut the PCs down as needed. Won't be many more of them. What do you mean, Wraith? Yes, YouTube now is Nightbot. Drummer, can we... The Nightbot over there needs to be toned down a little bit, dude. It's, I don't want it to mute people for caps lock and everything. Just have it zap people for links, and that's about it.
Discovery, go at throttle up.
Hey, Everest 37-month resub. The UPS allow for automated PC shutdown. Oh, really? Is that the USB 2.0 B to A wires that came with it? I mean, because I could plug them into Rusty. The way I have it set up, we could just run the wires from the 2 UPSs. Yeah, I could put in the provisions for that. Yeah, that USB 2 cable. Yeah, I have them over there. I could plug those in. Yeah, and we could run them. We could run them into Rusty to get that all figured out, or we could run them into the respective computers, right? Like, is that what we would do? Yeah, those wires let it shut down your computer. You should also be able to monitor the UPS battery life. Yeah, that probably is a good idea. So what do you think? Should I plug them into Should I plug both the UPSs into Rusty, or should we plug them into their respective computers? Windows will see the batteries. It works the same as a laptop. Oh, that's kind of cool. Connect the UPS to USB via the corresponding PC. Okay. Yeah, plug them into the respective computers. Cool. Yeah. All right, I can do that. We can do that. Hey, kiddo.
Discovery, go at throttle up.
Welcome to Mission Control. You go at throttle up. Thank you for the sub, dude. I appreciate it. Thank you very much. Good stuff, man. But yeah, regarding the car, after I got the UPSs and stuff, I did get back out into the garage. And so what I did with the two UPSs is that I plugged them in last night in the garage to get them to charge up those batteries. And yeah, they're up there doing their thing. Yeah, I plugged them into the garage, and while I was out here, I gave it a second to load up NDI. I did re-level everything. Guys, yeah, that leaf spring perch is welded in a little bit cattywampus. It's just a little bit off. If you clamp the thing down, I don't think it's going to be a problem. We were working on some alignment issues with the driver's side rear suspension attachment point. That's called a rear leaf spring perch. It's kind of on the left. It's on the left side of the screen there, where the clamp is on the left side of the car. Yeah, it's I think we can make the adjustments with it. It's a little bit out of whack. That leaf spring perch is just in a little bit wrong. It's a little bit tilted towards the left side of the car, towards the driver's side of the car. The reason why is because the frame rail was, when we put the bracer in, we put the bracer in on the frame rail that was rusty and kind of all over the place. And the frame rail came in, the bracer bar that we put in was crooked. So when I undid the bracer bar, the frame rail leveled out, and I had the leaf spring, when the frame rail was like this, I had the leaf spring perfectly level. And then when we fixed it, it's now tilted down a little bit. It should be okay. It's not, I could make the adjustments. It's really not a big deal. We could heat the metal up and kind of bend it into position to get it right, to de-stress the metal, like what I was talking about. But yeah, that's not that big of a deal. It's all right. I could like tack the thing into position. It's not a problem. It just needs like I said, the clamp is enough. Maybe moving it about that much, like bending it up, is what I need to do with that thing. It's fine. We'll just keep going. But what I am going to do with the car, guys, is I'm going to basically take we got to start mocking up everything. I got to put everything into position before we weld anything more, before we put the trunk pan in, before we do pretty much anything else. I have to really, I'm not going to make that mistake again. We got to put everything that goes back there back into position with clamps or self tappers or something. Like everything has to fall right back into place. And what we got to do for part 38, and I'm not sure when we're going to do this. What we got to do is really get all the parts out for the back of the car. So I'm talking the gas tank straps, the gas tank mounts, the filler neck for the gas tank, the bumper brackets, bumper plates, cross member extensions, trunk extension, everything. We got to put it all in place. That's something I should have done before I put the leaf spring perches in. But the good news is that I welded the leaf spring perch on the right in the passenger side one. That's welded in perfect. so that's good. That one is perfect. It is perfect fitment, which is, I'm not going to say that that's skill. I got lucky. I'm lucky both leaf spring perches aren't just tilted completely out. Yeah, it's the benefit of a jig. Yeah, if we had a lift, it probably would have been easier to make a jig. Don't have a lift. My accountant's an idiot. I called him yesterday. He didn't call me back. Getting a little annoyed still, but that's my problems, not yours. You don't want to hear about my problems. Let's play Kerbal. Okay, so where we last left off, we were looking for we were looking at defining our stakeholder expectations for the rocket. Ooh, I gotta go get my phone. Gotta put it on charge in here. I'll be right back. 1 second. Well, Kerbal is loading up. Former accountant. Yeah. Yep. Hey, Petrie. Sorry about this stream cutting out yesterday mid-convo about transmissions and stuff. Yeah. Both my computers crashed. But don't worry, I have since rectified that problem. We should be fine. Alright. I gotta go grab my phone. I'll be right back. Might be time to have a lawyer call him instead. Yeah. Yeah, dude. Yeah. Getting to that point. Okay. Were you gonna get new quarters? I think I might. My big problem with the quarter panels on that car is that they don't make those. They don't make those. So they only make 2-door quarters. So got a call. Dang it. I'm gonna go down to the house. I have another package of them down there. My routine is all screwed up because I wanted to mess with the UPSs today. Could you ask a metal 3D printing company to make them? Yeah. Yeah, Dean, they make patch quarter panels. That's not a full quarter for the Coronet. The problem is the patch panels are for 2-door. But we could get, they're not expensive. They're $230 a pop off Classic Industries. You know, that repop isn't going to be the best quality because it's $200. The highest quality quarter panel replacements are a full quarter replacement from AMD, and they're $500. Or actually, I think it was 560 something. I'd have to go look. I'm not doing a 2-door conversion on the car. That's out of my, I mean, it's not out of my skill range. I just don't really want to cut this car up that much. Any more than we already have. We have enough on our plate. So what I wanted to do is take the 2-door patch panels, cut those up, and part them, and basically cut them down to make my own 4-door quarter panels. And the cool thing about the patch panels is that they have the vents, the fake vents on the side, which I think are neat. So give me 1 sec. I can, so so where are those vents at? Here we go. So keep in mind, this is a 2-door car. So here's a 2-door Coronet. See those little, the vent indentations? The patch panels that I can buy have those. But the problem is that my rear door is right here. So what we could do, what I think would be kind of cool, is to cut the skin off of the rear passenger doors just in this area here and put the vents in. Weld those vents in. I think that would be cool. I think that'd be really neat. They did not put those vents on Coronets, on Coronet sedans in 69. They did a little bit on 68s, but not much on 69. So I think that'd be pretty sick. That'd be really cool. And, you know, we cut that out, and then we, you know, you cut the line for the door jamb and stuff and leave reliefs for the metal, and we can just put the patch in, and we can section that quarter basically on the accent line, or a little bit below the line right here. See this line? That accent line, you probably measure like an inch down, cut it, and then make a template out of the cutout panel and put that on the patch and cut it out appropriately. Hey, Thick, I'm doing all right. No, Dean, not at all. You guys paid for the quarter panels already. The quarter panels were funded in freaking July, dude. Yeah, I remember having this exact conversation in like part 30, I don't know, like part 31 of the Coronet. And yeah, I said my plan, and chat was like, oh, here you go. And I'm like, yeah, Tigers, leave an inch. Yep. So what I'll do is I'll buy the $230 ones. The reason why I'm going to redo the quarters is because, well, there's no quarter panel on that car from about here down. See where this lower accent line is? There's nothing there. It's gone. Like, if you go and look at my car, there's nothing there. It's gone. It rusted off. Oops. So, yeah, there ain't nothing there. What are you going to do? It's the car from the Northeast. What do you want? I think most of what was left of that quarter fluffy is in my vacuum cleaner and probably in that trash can over there. Yeah, you know, we vacuumed up the car a little while back. In the early episodes of the Crew Cab Coronet, we vacuumed up the car. It was great. I love that for me. Just vacuuming up most of your car off the floor because it fell apart. That's great. Was a Super B a separate car or a different trim level? So in 69, you could get a Coronet 440, Coronet 500, Coronet RT, Coronet Super B. 440 is the base. 500, which is what we have, is the premium trim. RT and 500 shared the same trim with stripes. The RT had stripes. RT stands for road track, not road and track. It's just road track. That is the like premium performance car, and then the Super B is the race car. Super Bs are crazy. Those go for crazy amounts of money. Yeah. So. Did you cut the infected skin off? I haven't done that yet. But yeah, that's my plan. We got to patch those quarters. We got to do the jams. The rear door jams on both sides are really struggling. Don't get me wrong, they haven't gotten any worse since I got as much of the rust out of them as possible and fiberglass and mouse nests out of there. But yeah, they're yeah, we got a lot of work to do. But once we get the trunk in, and like basically what I got to do, guys, is just mock up all the rest of the components that we have. We have to mock all of those up. There's no getting around it. Yeah, there's no getting around that. Got to do it. I think that's the amateur mistake that I made, starting to burn in components before, even if you measured them and stuff, you start to burn in components before they're really ready. What I should have been doing is fitting the trug pan as I was fixing the frame rails and putting the leaf springs perches in. That's what I should have done. So I'm not going to make that mistake anymore going forward. I will mock up all the components that I have before we even think about burning anything in, which You know what's stupid? I knew that. But when you're... I don't know, dude. You know, I knew that. I learned that. I've watched plenty of channels that all say that. But, you know, when you get to the point of, you know, applying the theoretical knowledge that you know, sometimes you still make dumb mistakes. Oops. Hey, Raiden, what's going on? Sphere, what's going on? Hey, dude, just wanted to say that I've really been enjoying your KSP streams. They really are my comfort streams during a quite difficult time for you. No problem. Yeah, my pleasure, dude. Well, with that being said, we should... And now I want to go mess with a car, but let's play some KSP. We have some design requirements that we have to finish figuring out for our new rocket, the Wonton rocket. Hey, J-Speed, what's going on? Content brain, it happens. Dude, I knew that, Hired. That's what's really stupid. I knew to do... every single freaking automotive manual about doing bodywork and you know, like restoration. I've read books about it. I've read books about restoring Mopars. I have a bunch of manuals down in the house that I read. Every automotive YouTuber that's restored a freaking B-body, everyone says to do that. Just mock up everything before you go. And yet, like, I knew that, and I still made a dumb mistake. Thankfully, I figured it out now, but I said I wanted to learn. You know, there's a difference between like knowledge and practical application. You know, I could easily look at the car that's rusty when we started and say, oh, that needs a trunk pan, but I didn't know how to do that. Now I know how to do it, and now I know how to do it right. So you learn from your mistakes. I did the same thing with my quarter, ended up redoing it 5 years later. Yep. Go Fever. Yeah, you're like, I want to show you guys something cool, but sometimes the process is, you know, which I also want to show all of, is quite boring. But, yep, paying the learning tax, that's what it is, man. Yeah, Hired, there you go. You won't make that mistake twice. So yeah, where we got to go from here is mocking up basically the trunk pan and anything that's back there. Anything and everything that goes in the back of that car. The tail lights, like whenever we're doing fitment and getting ready to put something in, we got to figure out how all of this jives together. Self-tapper things, and you use the tech screws and clecos to kind of put everything into position, keep them in their positions, and yeah, go from there. But yeah, we'll do that on the next car stream. I don't know, maybe I'll do it tomorrow morning if I'm feeling it, guys. I owe you guys a little bit more streaming content because I stopped early yesterday, so. Don't forget to spray it to stop the cancer. I cut most of it out, Chris. I'm not worried about that. Any spots that I didn't cut out have been coated in rust converter, and then primer, and then probably another coat of primer. The frame rails look like they've been dipped in paint at this point. They're not going anywhere. I'm not worried. Yeah, so we gotta sit there and we gotta do a lot more mock-ups. I mean, if you guys want to see that, you let me know. If not, I totally get it. I can just do it off stream, and I'll get back to. We'll pick up another car stream when we're ready to burn stuff in. Or I mean, I'm pretty sure you guys want to see the process, but you know, we'll see. If you think you're going too slow, slow down. Yeah. It's weird, dude, because like, if we go play KSP right now, I know exactly how to do it. I know how to be methodical. I know how to make something work pretty much on the first try, what tests to do, etc., right? And you'd think that would translate over into doing like hands-on stuff. It really doesn't. Like, it does to an extent, but not as much as you might think. MSC tonight. I don't know, dude. I don't know. How's your day going? I'm all right. Yeah. I'm all right. I got a lot on my mind, dude, but who doesn't? You know? So, let's jump into KSP and go. Yeah, geeked. Don't. Don't. No, not here. Anyway. Doing that sort of thing, making the first time is such a slow process that you're almost doomed to jump the gun. Yeah, for sure, for sure. Where's the wonton rocket? This is what we were working on yesterday. About as simple a rocket as you can make in KSP. We were talking about different styles of, this was on Tuesday. We were talking about different styles of launch complexes that we could do with this thing. What I did here was really get back to scratch. If you've watched my KSP streams before, this is some real basic stuff. I went back to scratch and showed people how to do basic analysis with the delta V and TWR formulas. How to do basic analysis on building a rocket in KSP, and provided you know a little bit about rocket ascents, you can get something very, very simple into space very easily in this game. Are you going to add fins or small thrusters for roll control? I haven't really figured that one out, Archie. Do we need roll control? Might be easier if we're going to... I want to attempt to make a guidance system for this using KRPC. But I'm not sure whether I should do that now or... I think designing the rocket first and building out its launch complex and then automating it might be the right move. Yeah, this is not a completed design by any means. I didn't really want to launch it. I knew it was going to work, guys, because of the analysis that we did. I launched it yesterday just because that was cool. But we basically sat here and put this rocket together, did all the calculations for it, and we knew it was going to work. The math says it's going to work, and the math doesn't lie. Like, the numbers don't lie. We verified that the KSP numbers here aren't lying to us. It will work.
Discovery, go and throttle up.
Have you ever visited other planets in mission mode before? Like flyby or rovers? In the last mission mode 2 save that we did, funny man, well, I mean, my older mission mode saves that are using the MM1 rule set, yeah, went all over the place. I mean, I went to the moon, we went to Minmus, we went to Duna, Ike. Yeah, we went all over the place, dude. The mission mode 2 save got to the moon. We had a program architecture that got us to the moon pretty reliably too, which is super cool. Yeah, I don't think MM2 got further than Minmus. Yeah, Prey, I'm not sure I want to do that way. I would prefer to have roll control, because, okay, my rationale behind that is having roll control, I think would be a wise option, because, so one, communications antennas. I like you have the antenna facing in the right direction. That's not really a thing in KSP, but it is in real life. And also, I'm fairly confident it would be easier to program if the vehicle rolled an established flight azimuth. Because instead of, doing what you're saying, doing pitch sweeps, right? And then basically toilet bowling the vehicle to get it to turn, with your guidance system, you would just be controlling the ascent via your pitch axis, and having your artificial horizon coplane, or having your Vehicle orientation coplanar with the artificial horizon, relative, except for pitch, might be easier to code. Yeah, am I wrong? I mean, there's limitations of that, I understand, but I don't think using sweeps is the right. I don't think using. Let me rephrase that. I don't think using sweeps is the right place to start. You know. Yeah, Christoph, that's what happened, dude. Sucks. What about the bleeps, the sweeps, and the creeps? You know, we may have lost them. You're right. It's a good enough justification to not do it. Always interested to question what you'd need to do in order to delete something. There you go. I mean, the other thing that we could do is start messing around with this thing. I don't like fins, guys. I mean, fins on Kerbal rockets are perfectly acceptable. But, so remember, today, for part 2, we have to start figuring out how... We built a rocket. That's great. That's great if we're just playing KSP and just sending it. We know it works, right? But that's not what we're doing here. We're making a guidance system. And then I want to build a launch pad for this too. I want to show the end-to-end thing. Because in real life, you don't just build a rocket. Okay, now we're good. Now oh, here we go. Let's fly into space. No. You're thinking about all the systems. Everything that makes that thing come together. You don't just build the thing and be like, yeah, okay, here we go. You need to find a way to turn it up right. On top of manufacturing in real life. I mean, we abstracted the manufacturing. Manufacturing for us is just clicking over here and putting the engine there. Right? In real life, you have to take into account, like, okay, if you want to launch this rocket every 2 days, you know, and you have a partially expendable system that doesn't get your second stage back, and you want to launch 150 times a year, right? Your factory's going to need to be cranking out a second stage every 2 days. Spoiler alert. That's what Hawthorne is for. SpaceX's headquarters in California, or their factory in California. I don't think they're headquartered there anymore. I think it's in Bastrop, but whatever. The Hawthorne facility. They got to make a second stage every 2 days, dude. Think about that for a second. That's crazy. Have you decided what type of transporter erector, Newcastle transporter erector you want to use? No, I haven't thought about it. I think trucks would be cool, Hellfish. I think trucks would be awesome. That's kind of a cool idea because your pad is mobile and it would be easy to move it. It's easy to fix things, right? If you really need to. But, I don't know. I think we should get into that conversation today. Trucks could be cool. I could do that. I could build... I have just the chassis, believe it or not. It's got... Yeah, exactly, Shaw. I'm not sure if that gives off the right impression, dude. That's why I kind of think, like, not making it one gigantic missile system, but we could make it trailer-based. Like, the launch pad could utilize, you know... a semi-truck trailer. Like, we can make that. We've made it with the K200 before. However, I do have a chassis that might be wise for what we're doing. This chassis right here. Now, this one, I mean, this thing's pretty cool. For sure. You know, I have one with the stops. You can deploy the stops and it can raise the truck up and you know, it can level itself, etc., etc. I think utilizing a semi-truck and trailers for the launch complex could be a useful thing to do. Good evening. Did I miss some important KSP lessons in the first few minutes? I don't know. Why don't you rewind and find out? No, not really.
Discovery, go at throttle up.
Hey, Fozzie. 69-month resub. I don't know, man. I think the trucks might be complicating things. You found a truck called the DF41. Hello, baby. That's the Dongfang 41, right? Yeah, this freaking thing. That's based off of the... okay. Starbase Live with the truck backing up is a little distracting. Yeah, this is just a submarine. It's a freaking submarine tube. Well, kind of the same idea, but... that's a, I don't know, man. I don't really want to make that like that. I mean, it's a cool thing to do, and it could be useful in KSP, but I mean, there's a that's a see, that's the Russian truck right there. Oh, someone's done it. Nice. I don't really want to do this like this. I think trailers would be a better thing to do. Oh, dude. Looks so good, dude. That's such a cool car. So... we could end up doing something like Rocket 3.0. But once again, that's going to get a little bit complicated. Astra's Rocket 3.0, all the launch pad components and the rocket can fit inside of a Connex. It can fit inside of a shipping crate. That was done on purpose. That was part of their design. That was part of their stakeholder expectations. The UPS issues are all solvable, yeah. The reason why I think it's okay is because show the bridge for military peaceful. Please make it stainless, whatever you do. I mean, Space Ghost, we could do that, yeah. What about your suborbital launcher from MM2? We could build off of that, Hellfish, yeah. We could very much build off of that. That was pretty cool. I kind of want to show people this thing. But yeah, if we were going to do like a single truck launch vehicle and stuff, I'd use this chassis. This chassis is mint, dude. It's a crane. It's a gigantic crane. It's a beefy telescoping crane. And when I say beefy, I mean beefy. It is a monster of a vehicle. I think trucks and trailers would be a better way to do that, Shaw. And if we have the transporter erector be a trailer that attaches to said pad, right? If the thing breaks, you can just swap it out. You just swap out a component. So you're inadvertently making your launch pad very modular that way. Kind of want to show you guys this thing. It's pretty neat. Just on a side note, like I'll show you where this could go. Patch, so KSP show and tell with EJ. It's one of my favorite parts of these streams. Yeah, well, we can't do it for long, but. All right, get up the side. There we go. So with this crane design, I was prototyping a we were prototyping a way to have so this crane has to be assembled. Well, not assembled, strutted into position is the right way to say it. What you got to do? Do I have another controller for these things? Jack's control right there. All right, you got to get them. You got to get the outrigger controls straight. Now we go here, and we go Control I, and you start running struts. You can do that with Kerbal inventory. You could start running struts that hold all this stuff together. This is actually probably a good way to test all this out, just to be sure that it works. I don't remember if this is the right way to do this. I could have sworn that there's more struts to run, but I think here with this design I did run struts to the hydraulic cylinders like that. Bring back my idea from last time. 2 flatbed trucks and palletize this stuff. Do we want to unload from the flatbeds, dude? This is all stuff to think about. What are our expectations for this vehicle? Does this vehicle need to be quickly deployed? I think those are good questions to ask. You know? I mean, if we're just gonna make it on trucks and stuff, dude, like, that usually calls for a quick design. Like, are we trying to do exactly what Astra's doing? I don't really think so, man. Plane launched? I don't like doing plane launches in KSP. You have to fly in a very, very, very specific trajectory to be able to get your launcher back. And making launch complexes for stuff in KSP is already difficult, dude. I really don't need to make it any more difficult by making my launch complex fly. If that makes any sense. Okay, so now we got to go over to the Jax controller. Hey, Lunar Lander, 4-month resub. Let's play the controller. Switch back to the crane. Lock out the hydraulic jacks. All right. Now I think we're ready to deploy. Is the smallsat launcher intended for rapid response? Not really, no. I mean, this launcher we would want for this launcher would be used for a mission mode style save, so we'd be looking at pretty frequent launches, and I would want to be able to put it together on some reasonable time frame. It doesn't need to be instant, right? Hydraulic yak. I hate how floppy the back of this damn thing is. Okay, now how did I do the rest of this damn thing? Okay, we got to get the ears up here. Oh, okay. Hold on. I see what we have to do here. Let's reverse that and bring it down. We have to put the pendants. We have to attach the pendants. Have you ever built a rail and train in KSP? It's possible, Flykin. You can do it. Who did it? Stratton Litz made a train. It's possible. He made a monorail in KSP. The monorail that Stratton Blitz made, dude, utilized the same idea as that I do for my gantry crane rails. He had the fuselage inside of a fairing, and then he edited the fairing to be like miles long and made a track on the moon. It was actually really, really cool project. He has a video like that out there somewhere. All right, so we lock. Lock those into position. So these are here to prevent deflection, right? And now we need Bill back here. Like, the reason why I'm showing you guys this is showing like what can be done. Like, you could build launch pads this way if you really want to. Like, using this style of building, it is doable. It's difficult, but it's doable. So we can run a strut from there to there. You could do the same thing here to there.
Oh, this is space. I'm in space.
Chuck Norris gifted a sub to Sututive. Cool. All right, now what we got to do is extend the boom. Boom length. Play. Like I said, I can make cranes. We can use these. We can lift stuff up with them. It's not a big deal. This thing can lift a good amount. It has a huge freaking counterweight. And I don't like how the counterweight deflects. That's really annoying. I would really... Something that would be useful would be to make a crane pin, a crane turret, like custom modeled. That would be a pretty good thing to do. So these are what's called crane pendants. The pendants are used to, they're basically struts. They're struts that can move on certain axes. Normally you wouldn't set up pendants like this floating in the air, but here we are. Make sure there's no stress onto the boom right here. And then switch over to Bill. Bill's gonna need to swap his problem with this is that the damn pendants are moving around. There's got to be another way that I did this. They're deflecting, but yeah, whatever. Let's just get it done. Let's see if it works. Yeah, you're getting some nasty deflection here. That deflection is not going to be great for the crane design. It's going to put stress right there, but it's all right. Adding some lateral stability might be a good idea there, but it's all right. Yeah, what happened during yesterday's stream? Is everything okay? Yeah, hey, Mats, thanks for asking. I had an undervoltage on my computers. Both computers blue screened at the same time, the encoding and the gaming PC. Not great, dude. I diagnosed the problem. I figured it out. It was my UPS. I was running both my 1,000-watt power supply computers, all 5 monitors, all my lights, and all my auxiliaries, the mixer, everything, through one UPS, a 1500 VA UPS at 900 watts, and it was just overloading it, dude. So I went and bought 2 sine wave UPSs. So I have 3 uninterrupted power supplies now. One is going to each computer. They're all 1500 VA 900 watt. The 2 that I bought are sine wave UPSs. They have a voltage regulator of power and a the thing to clean the power. I forget what it's called. The sine wave thingamajigger. Sine wave inverter? I don't know. It doesn't matter. The 2 sine wave UPSs are plugged into each computer, and the existing UPS is plugged into all the monitors and everything. So yeah, I didn't come back last night. One, because Nusantara Lima scrubbed again, and I didn't come back because I didn't want to risk undervolting my brand new computer, dude. Okay, we gotta unpower all these if we want the pendants to work how we want them to. Cab wobbling was giving diesel idle vibes. Yeah, right. Stop. You see how this thing dances? I can't stand that. It's the stupid robotic piece. But yeah, I mean, we could go about building a launch pad this way if we really wanted to. It is a thing that we could do. What mass is it rated for? I don't remember. We have 15 tons of counterweight right here. So that's 33,000 pounds of counterweight. Or, yeah, close enough. It could lift up something pretty hefty, dude. We have a lot of counterweight and the vehicle mass is 68 tons. So we could pick up something pretty hefty with this dang thing. So the cool thing is we turn the joystick, right? I have the joystick bound to CAL controllers. You turn the stick, the crane will rotate. You pull back on the stick, it'll extend the crane. Lock the pin, bring this down, and now you can pick something up. And then we just got to make sure we start the crane's fuel cells. You got to open up the engine bay here. Start up the fuel cells. There you go. So there you go, an assembled crane. Totally doable. You can absolutely do this. Yeah, a crane in KSP. This crane is similar to the one that SpaceX had in the ring yard at Starbase. This is a telescoping crane. This is about as big of a telescoping crane as you can make before you have to switch over to like a lattice crawler or something. But dude, she can lift. It lifts up stuff, dude. If I didn't park the damn thing on the runway, I would drive something out here and pick it up. It doesn't have the biggest lifting capacity, but something like this could easily be translated into building like a launch pad or something. Yeah, you could use it to build all kinds of stuff. Yeah, being able to control the crane with a stick. It's pretty cool. Yeah, this is like, that's what I mean, guys. If I want to build a launch pad on a truck, we could do that. That's easy. I'm not sure I want to do that. Now you need 10 to 20 more and you'll have a fleet. A classic style launch pad of a small rocket like this would consist of a small stool with a strong back, pretty much. So K3, I was thinking, you know, I like this, but something like the Atlas. I mean, Astra is cool. I like Astra's rocket. That's pretty neat. Their GSE is actually really, really good stuff. But what we also could do, like if we go Atlas 2, Atlas 2 is a little bit on the big side. Let's go Atlas. No, you know what? Let's go SM65. So the original Atlas missile, and by proxy Mercury Atlas, right, was it had a trying to find it. There you go. Actually, the missile, look at that. That's similar. You know what? I never bothered to go and look at this. That's Rocket Lab. That's the same way that Rocket Lab does it. Huh. I'll be. That's interesting. Look, it's a transporter erector, or just an erector. It's not a transporter erector. It's just an erector that grabs it at the top, just like Rocket Lab. That's exactly what Rocket Lab has. I didn't realize an Atlas did that as well. Never went to look. Huh. Now Atlas also. Hey Urban, where are you thinking you'll set up your pad? I have Kerbal Construct, so yeah, it'll probably end up getting set up here, but we could, you know, depending on how we make it, we could transport it around and move it wherever. See, the Atlas was moved on a trailer, and the trailer, that trailer is actually super cool. It's designed to fit in a what's the name of the cargo plane? It was designed to fit in a cargo plane. It wasn't a C-130. It's not a C-123. It's not designed to fit in the Guppy, no. It's a 121 is the Connie. 24 maybe? No, that's not it. That's cool though, but that's not it. I always forget the name of this damn plane. Cool plane. You know what? It's in Pima. I'll show you. Maybe somebody... It's not a boxcar. It's not a C-119. No. No. I know one of them is in Pima. I've touched it. It could be a 133 Hangman. That sounds right. Where's Pima? There it is. It's over here. That thing. That. I think, I mean, it might be a 133. Yeah, that's it. It can fit in that. That trailer with Atlas can fit in it. I'm not sure if that was a design requirement for that thing, but it can absolutely fit inside of that plane. There's the one at Pima. That's the one that we just found. That trailer is specifically designed to fit in this plane. I can't prove it. Like, it probably says nothing about it. Hey, Matt, your name's on this thing. It's military air transport service, but whatever. Yeah, no, whatever. It's fine. Whatever. We'll just believe that they put that on there for you. Okay. T-133 was a U.S. Air Force turboprop transport aircraft designed to carry the large first-generation Atlas missiles. There you go. Does that say that in here? The C-133 carried many large heavy loads, including Atlas and Titan ICBMs, although it was not designed specifically to transport ICBMs. Thanks, AI. Very cool. Indeed, it may indeed have been the reverse. C-133 design was frozen in 55 to build other airplanes that first flew in 56. The designs of both Atlas and Titan were not firm until after 1955, when their contracts were signed. The C-133B with the rear cargo doors were modified to open to the side, making ICBM loading much easier. Air transporting the ballistic missiles such as Atlas, Titan, and Minutemen were much less expensive, safer, and faster than road transport. Yeah, it wasn't exactly designed for it, but I don't know why the AI overview is going to say it says the exact opposite, but I don't know, maybe Wikipedia is wrong, who knows? How big can you build such a plane? Oh, you could build planes pretty big, dude. Oh, I remember now. I remember. These struts weren't there to the housings. You'd run the strut to the piston base so it doesn't do that. See that? That's Kerbal's way of telling you something is getting crushed. Kerbal doesn't have soft body physics, right? It's not like Beam. If it was Beam, that thing would be crumpling right now. But Kerbal doesn't have that. So Kerbal just kind of... The game's way of telling you something is getting crushed and something's being bent, or it's too much point load here, is that. That's always look for that. With landing gear, guys, you ever built a plane in KSP, and you put it out, and it just moves to the side? That's the game's way of telling you that you don't have adequate landing gear. You need more. Put more landing gear on it. That's the landing gear can't take the load. But yeah, there's a crane. I don't really remember what this thing can lift. I know it has trouble lifting up another truck. Loading of an Atlas into a C-133. Yep, Atlas had the trailer that was designed for that. Yeah, exactly. Let me get out of Google Earth. See? The Atlas was designed to fit on that trailer. Fun fact, the trailer for the Atlas, which is also the erector, for this version of Atlas, it looked like the early versions had that Rocket Lab style transporter erector. The later versions of Atlas, the trailer is the erector. Yeah, the trailer is the erector. Now, do we need to make the trailer the erector? I don't know. Like, okay, say we make the trailer the transporter and erector, and we make it able to be towed around by a truck, right? Say we do that. Okay, so the trailer goes and launches it again, right? You know, we have our wonton rocket on the trailer, right? We attach the trailer to the pad, turn it upright, right? You know, trailer goes back, we launch the rocket, you take the trailer, bring it back down, hitch it up. Now what do you do with it? Recover it? What are you doing with that thing? How do you load another rocket onto the trailer? Or do you just put the rocket out on the trailer? What do we do? I have not, Illness. See, this is what I mean. If you're going to build out the whole system, you got to think about this stuff. This is every rocket that, you know, we see launched, every rocket that we cover, you know, Firefly Alpha, Astra 3.0, Electron, what other small sats are there around? I mean, Minotaur too, to an extent, right? Every single rocket, even Falcon 9 had all this. You had to think about all of this stuff before you even thought about launching this thing. You got to think about it. Think about what are you trying to do? What are your expectations for this vehicle? I don't want to rocket up your tailpipe, Mats. Oh, okay, cool. Yeah, I got you. That's a good expectation to have, dude. The trailer idea is super cool, but in Kerbal, I don't really see how that's all going to jive together. Like, what's the point of that? What do you... Okay, so we have a trailer that's our transporter erector. It'll make it super easy to turn this thing upright, right? And then, but what do? You detach the trailer from the launch pad every time? Do we really need this launch pad to be anywhere? We could make it anywhere. Like, the plus side of a trailer is that if we make the transporter erector and rocket a trailer that can be towed around, you could theoretically put that in an airplane and send it to the desert, right? You could do that, but why? Why do we need to do that? KSC is like, I just don't really think that we need to do something like that, you know? I don't. Why? Why do that? It is very interesting to me that the original Atlas, I think this is I'm not sure if this is an SM65 or if it's an Atlas like A, B, or C. Does it say? I think that might be just the original SM65. If you want to launch missions from a different pad, yeah, Sun Temple, but okay. Say we're making this rocket for mission mode, right? Say we're making Wonton for mission mode, right? For all intents and purposes, I would like to abide by mission mode rules for this build, but we're not in mission mode. I'd like to do that just because, right? If we're gonna do that, I want the pad to be reusable. That's the whole point. And I want it to be reusable and quick. But I don't want it to be like missile truck quick either. Like if I made the pad, right? If we made it into a truck and we made like a missile launcher, all right? I wouldn't just recover the truck. I would want to keep the truck out there. I'd want to keep it out there. And I'd want to make another system to just load stuff up onto the truck, right? To reload the launcher, so to speak, with a new payload. Just don't tip over like the crane at Massey's. Yeah. Check out the Chinese Kuaijiao 1A. Okay, Ruin. Huh. See, that's exactly what I'm talking about, dude. That is one of their that's one of those military trucks to launch the ICBM, but they have a transporter erector on it. And the erector puts it up on a pedestal. And it doesn't look like this rocket. It looks like this rocket might be SRBs or something. And the Feichen Emergency Satellite Launch System consists of 3 solid fuel stages and a liquid fuel 4th stage. It's an ICBM with a payload fairing on it instead. I mean, we do stuff like that too with Minotaur. So, like, if we're doing something like this, the truck drives back to what? Do we reload the truck? Do we recover the truck and put a new one out? Like, what do we do? Maybe something like the suborbital pads from the Starship test flights. Well, that used a crane to put a rocket on a pedestal. They used cranes to do it. There was no erector structure. It was just a crane. Atlas was also silo launched. It was raised up out of the silo before launch. Yeah, Kai, Titan was like that as well. Titan 1, excuse me. Titan 2 was not like that. You know what you're doing? You're putting a rocket on a pedestal. You know, these streams are important to explore these ideas when you want to go and do this stuff. Look up Mad Mike Hughes. That? No, I don't need to look that up, dude, Sim. That is not really what I'm going for. That's a rail-launched vehicle. A deadly rail-launched vehicle, might I add. We don't need to look that up. Put the rocket horizontal on the runway and have the truck drive under it. Drive the truck back to the B&B, recover it, and set it back out on the runway afterwards. But you would need to have launch locations away from the runway. But that's just me. Dama, if we have to recover the transporter erector every time, that doesn't strike me as very reusable, you know? I'd rather have the transporter erector affixed to the pad, if that makes any sense. He was right, though, about the line in space after he died. SpaceX managed to have its first rocket landing vertical or something. Can we not do this today, please? No, he was not. Guy was a stuntman, dude. He's a stuntman. He's Daredevil. Basically put a seat on top of a water heater and depressed the water heater to try and fly into space. Problem is, he didn't do proper testing with his parachutes. And his parachute deployed on liftoff. Bad things happened after that. That is not even close. To even suggest that that has any inkling on any of SpaceX's operations is downright wrong and disingenuous at best. Don't even go there, dude. Brother, just don't. That's not right. Now, I will say, I give credit to Mad Mike Hughes. He had the balls to strap himself to a rocket that he made. Problem is, rocket science is difficult, and he found out the hard way why it's difficult, which really sucks. But it is what it is, man. Yeah, he definitely grifted the flat earthers pretty hard to get funding for his project. Turns out the guy ended up he was a stuntman. He was like Evel Knievel, which all right, that's cool. But nah, that has nothing to do with SpaceX, brother. SpaceX had plans on reusing rockets as far back as 2010, dude. That was way before Mad Mike's time. Wasn't there a version of Titan that could use multiple types of fuel? Titan is one of the only rockets with the LR-87 engine that ran on 3 different types of fuel. LR-87s can run off hydrolox, they can run off kerosene, or they can run off hypergols. The reason why is because the drive pumps, the fuel pumps, on a Titan style, on an LR-87 are gearbox driven. So in the very same way that you can change the gear ratio, the final drive, like a quick change rear end, on an automobile or a race car, the Titan's turbo pumps had a drive system where you could change the gear ratio between your fuel impeller and your oxidizer impeller, so you could have them run at the right speeds for different fuels. And the LR-87 ended up being a motor you could pretty much run off anything, which is really cool. That's really neat. Really smart way to do that. I know that it did that because I've held the gears for the gearbox in my hand. Didn't do that on stream, but almost did it on stream. Look at a Discord post picture of the B2 landing at Whiteman. Okay. Sorry, if I scroll on the other thing, that's neat, man. It's cool, but why? That was more just to see if they could. Titan 1 rockets ran off kerosene. Yeah, it was a Keralox rocket, and then they switched it with the Titan 2 to hypergalls. Yeah, pretty cool, huh? I've hugged an LR87, dude, on stream. That was pretty neat. I hugged it because it's an LR87. There's a reason why I named my dog Titan, dudes. I love Titans. Titans are cool rockets, man. You guys got to understand, Titan 3s were basically the Falcon 9s of their time. Pretty cool. Like, that was the workhorse rocket back in the day, in the in the 70s and the 80s. Really, well, for part of the 80s, and then Titan 4 came along. But yeah, 70s and 80s, Titan was the rocket, dude. That thing was a beast. The Titan was our Soyuz, so to speak. Hey Hangman, thoughts on a static reload stand that you bring the transporter erector back to reload to VAB to reload? Just recover the stand. So Hangman, my question is that if we have to drive all the way back to this static reloading stand, right? If we have to drive all the way back to the static reloading stand, why don't we just make the static reloading stand vertical, or mobile, not vertical? Why don't we make it mobile and leave the transporter erector fixed? Isn't that quicker, right? That's quicker. So you have your static stand with your rocket on it. You drive your strong back transporter underneath it, drop it on there, right? Drive that back to the pad, turn it upright, launch the rocket, bring the trailer back, right? And then you bring it all the way back to the stand, right? You know, recover the stand, put another one out, put it on again, right? If we just had the rocket spawn on a transporter vehicle and had the erector fixed at the pad, you just put the vehicle out, drive it to the pad, load the rocket, turn the rocket upright on the reusable pad, launch it, right? Take the vehicle, recover the vehicle, right? And then put out another one, right? Like, how granular do we want to get with the integration here, dudes? I like the way that I said, Hangman. There's less steps involved here. That, I mean, granted, that is exactly how I did it with the Imahara rocket. Anyway, this is the crane. The crane is super cool. We could build that into some type of transporter or something. But yeah, Hangman, I like where your mind's at. That's not a bad idea. Did I ever finish? Oh my goodness, I never finished it. Stage recovery vehicle for splashdowns. Never finished it. It's pretty good, dude. It's a pretty good design. Fair point, just thinking of ways you don't need to recover the transport. I mean, yeah, if we don't want, like, but yeah, Hangman, what I'm thinking is, like, we don't recover the transporter, might as well just leave the transporter at the pad. Why make it mobile in the first place? That's just more parts, right? It's just more steps, right? I appreciate where your mind's at, but yeah. Yeah, that was a transporter ship that I wanted to make. It was supposed to go fish out my shuttle boosters. It was gonna have a crane on the back. We did something else. We decided to change paths or something. Let's see, orbiter, lift bracket. And there's the shuttle my shuttle. There's CTS-5 and its transporter. We should use that thing. What about wheels, hinges, and docking ports for the TEL? What about wheels? Prone to crack and strike. Hinges, prone to drifting. Docking ports, prone to crack and strikes for the TEL. That's the other reason why I really didn't. Okay, so here, let me show you. Let me show you how we did it. Here. This is Imahara's launch pad. That's it. It is inspired very heavily by Electron's launch pad. Overhead transporter erector. You know, you have a track, you have rails, right? You back the thing in here, right? And you stiffen this. My way to do this was to stiffen the suspension on the wheels and get the truck to raise up, and it raised it into position, clamped it, and then docked. The only real weird thing about this pad is that I used that same docking port to refuel the pad. So the pad is like, if I want to refuel it, it's refueled through the like if you want to refuel the fuel farm, it's refueled through the transporter erector. I mean, once again, this isn't a bad design, dudes. It's pretty good. I'm just like, see, I'm wondering how, like, I don't know if Astra ever showed it. Like, did Astra ever show how they put their rocket on the transporter erector? I don't think they ever did. There's rocket 4. Why not use Imahara's launcher for Wonton? Well, we'd have to modify a couple of things, Tigris. But yeah, we could. This was okay. The problem with this is that we had drift all over the place. That was the real big issue with this pad. You could only use it a certain amount of times before it broke. It was a refurbishable pad, not reusable. That shuttle looks awesome. Oh, yeah, Mats, that's CTS-5. My 5th generation space shuttle. That thing is about as close to the real one as you can get in stock KSP, at least from by me. I don't think I can build better than that thing. It flies exactly like the real one, dude. Everything is where it should be, down to the fuel cells, payload bay lights. It's got a robotic arm. The robotic arm kinematics work exactly like the real one. Well, not kinematic. Well, yeah, kinematics. It works exactly like the real one. The antennas are all in the right spots. I have a panel on mine because I made the TPS out of smaller panels. What's up, Muffin? Dude, this thing flies excellent. It don't get better than this thing. Don't get better than this thing. I can't make a better shuttle. And you know what's cool? This shuttle could theoretically be reusable. I never built a launch pad for it, but you could. And see, I have external tank rear aft strut external tank alignment pins in here that are made out of cubic octag struts, so you could attach a new ET to this. And the shuttle utilizes where the forward bipod strut is. It has a docking port, and I did some clever Kerbal heating dynamics here, putting the docking port on the bottom. You know, you'd think that, oh, it's going to absorb a lot of heat. No, it's behind. The game registers that docking port as behind the panel, so it never blows up during reentry. What I mean behind the panels, I mean behind the panels, not aerodynamically, but behind the panels hierarchically. How Kerbal heats stuff up, dude, is whatever is up at the front of the vehicle, right? It's going to get heated, right? And then depending on the aero, it calculates thermal that way too. So basically, say that nose cone is your root part. The docking port is further back down the hierarchy. The game thinks it's lower on the vehicle, so it doesn't burn. So this shuttle is reusable. Dude, you could reuse it. What it does need is hoisting points. I never built the hoisting points in because we never got that far. I think we never got that far because Kerbal 2 came out. Oh, the other things. I figured out a way to reuse SRBs. Yes, you heard that right. Reuse SRBs. I can refuel them without putting a new one out. We can refuel them. Yeah, if you take a cal controller and bind the thrust limiter on the SRB to a negative number, it'll refuel it. So I can refurb SRBs too, if we really needed to. Yeah, exactly, Daitor. Is RCS in the correct places too? Yes. The RCS could use a little bit higher fidelity mock-up. The RCS for that orbiter is Kerbalized, Dan. So, yeah, it's Kerbalized. So it's not exactly it, but yeah. Do you have to fire the SRB to refuel it? Yes. So Jim, how you would do this is if we made some kind of stand, actually I'd probably end up doing this on the launch pad. So you could transport, so the SRBs are easy to transport, right? My plan here was to fish the SRBs out, fish their nose cones out with a boat, right? Bring them back, right? Put them on a cart, tow them back over to wherever we ended up putting a shuttle launch pad, and putting them on it, and have the thrust inverted cal controller there. So when we put them back on the launch pad, we refuel them. We invert the thrust controller, right? And then you disable the inverted thrust controller, and to make sure that the SRBs don't go off again, you set their thrust controller to 0 because they're technically activated, right? You activate them. So when the shuttle gets back on the pad, right, and you go to launch it, instead of a cal controller telling the SRBs to activate, I would have my shuttle's flight computer, the cal controllers on the orbiter, I would have to rebind them to the SRBs, and at ignition, set their thrust ignition to set the thrust limiter to 0 during from 0 to 100 during separation, and you just play the thrust limiter controller. Because the way this is set up is that I have a cal controller set to a progressive thrust burn here. The thrust curve. See it right there? You wouldn't even need to have it reset. You just activate the thrust limiter. You activate this cal controller, and it'll dial your thrust for you. Note that my SRB thrust tails off in time, and they don't flame out. They ramp down in thrust over time to get the shuttle to fly like the real one. So yeah, and then also I'm pretty sure I made this mechanism up here for the nose cone. Oh, it's on a decoupler. It's not on a it's on a decoupler. It's not on a docking port, so I'm not sure how well that would work. We never dialed that in, but I built the provisions for it to work. So yeah, Jim, all you'd have to do is have your SRB fueling and reload controller. When it's done refueling, you set it to 0, and then the next time the SRB goes, you just activate that cal controller, and it'll plug your thrust right to 100 during liftoff, thereby making the SRB fully reusable. Yeah, I can make reusable SRBs. The other thing is that you'd have to do the same thing with Separatrons. Same thing would have to be done with the SEPs. This sounds extremely complicated, but that's why it's so dang interesting. But he said rocket science was easy, homie. Last time you did this, if I recall correctly, your biggest problem was slowing the SRBs down. Well, because we opted for an asymmetric shuttle, okay, we have our asymmetric separation system, guys. Now, look at the SRBs. Okay, look at the separatrons. So if you look at the center line of the SRB, look at how close those separatrons are to the mouse cursor. Now look over here. Do the same thing over here. Look. It's an asymmetric separation system. Not a lot of people know that. The shuttle separated its SRBs asymmetrically. One kind of goes up and to the right, and the other one goes sideways. Actually, one goes kind of, well, they separate down. Like if the orbiter is right here, one of the SRBs goes out and to the right, and the other one kind of goes out and to the side. And they kind of do this when they separate. You know, it looks like it's symmetrical, but it's not. They're slightly asymmetric. The reason why is to make sure the SRBs don't hit each other on the way down. So if they have an asymmetric separation, right, they're never going to flip around and hit each other during a sep, right? You don't want that to happen because you're reusing them, right? So, JSpeed, my problem is that because of our asymmetric separation, the SRBs get too far apart from each other. So when you switch back to them, it's really difficult to, you could switch to one, but not the other. So at best, I might be able to reuse one SRB every flight because the Kraken likes to eat the other one because I can't switch to it in time. Using the cow controller to limit actual SRB burnout is brilliant. Yeah, Pashto, the SRBs do that in real life. They're programmed to throttle, but they're not programmed to throttle. They're hard coded to throttle because it's the way they physically pack the fuel inside of the SRB. The SRBs, you know, everybody knows that the shuttle throttled its engines back for max Q, right? Everybody knows that. The SRBs also throttled down for max Q because, you know, as it burns more and more, there's a point where they change the shape of the grain and it actually caused the thrust to go down. Actually, that would be an impingement in SRB design, but potato, tomato. Pretty cool, huh? It's called a regressive thrust curve. It's absolutely a thing. Only interrupting because new B-21 flight pictures. Neat. I thought, have you considered trying to get sponsored by Rock Auto for your wrenching bids? No. I don't buy from Rock Auto. Not all the time, at least. Thanks for the distraction. It's been a rough couple of days. I know what you mean, dude. I know what you mean. Don't. But yeah. So, yeah, that's my shuttle, Matt. It works exactly like the real one. It flies exactly like the real one. Ascent, descent. What this shuttle really needs is a software component for the robotic arm. That's what it needs. The reason why is because using the robotic arm, quote unquote, by hand, where you have to adjust every servo after you make a movement, it makes it really difficult to do missions that utilize the freaking arm. It's really tough. So what I ended up doing to overcome that is I have a blank programmable cow controller in here called RMS program. And the way to do it is to sit in the SPH and program all the animations for the arm to like pick up a module out of the payload bay, take it, move it, and then attach it to whatever else you're doing. That's the way to do it. But that sometimes doesn't work as well as you want. But yeah, that's the idea. You never buy from Rock Auto. No, it's not that I never buy from Rock Auto. It's that most of the parts that I'm getting for the Coronet right now, Rock Auto doesn't have. They don't have trunk pans for a Coronet as far as I know. If you look at my toolbox out there, it's covered in Rock Auto stuff. But I don't, I haven't bought from them in a little while, dude. Dude, I don't want to talk about this. Can we go back to talking about rockets, please? So, yeah, that's the shuttle. Thanks, Matt. That's a lot of work, dude. Right there is about 6 months of project development, dude. Yeah, that was 6 months. Took me 6 months to build this thing, dude. Everything, and I mean everything, is right. Everything is where it should be. The external tank works exactly like the real one. The SRBs work exactly like the real one. The shuttle heck, it even flies like the real one. Actually, I still think that CTS 5 runs a little bit. This is more because Kerbal's atmosphere is a little bit thicker. Again, the atmospheric density picks up a lot faster. So around the surface, because your atmospheric pressure builds up pretty fast when you get towards the surface. I think my shuttle actually flies a little bit too good, but it still flies like poo-poo. At subsonic speeds, I think it flies a little too good. We'd have to make it fly worse, chat. The right way to do that would be to replace most of the bottom of the shuttle with panels. Like all these wings up here, replace them with panels, but yeah, I'm not gonna do that. Yeah, it has to fly more like a brick. It flies too good. Just a little bit too good. We could go in the wind tunnel and mess with it if we wanted to make the Block 2 variant, but yeah. I'm fine with this thing working just the way that it does. It's good enough to get the point across. Works exactly like the real one, dude. Within the confines of KSP, it is a Kerbalized version of a space shuttle. That was not easy to do. The shuttle's an extremely complicated system. But yeah, Mats, I even built potential reuse into this. This, you could, with the right cranes, you could theoretically stack this. If I had a VAB, if we built a VAB in game, we could make this. We could reuse it. We figured out ways to reuse the SRBs. Even my attachment mechanisms are mechanical. So I have a ball and socket here on the SRB for alignment purposes. So you could drop, like how they stack the shuttle is they stack the SRBs first, and then they hung the external tank on the SRBs. And my SRBs have alignment pins right here. So the highlighted part is attached to the external tank, and the highlighted part there is attached to the SRB. It's a cup, right? So if we wanted to, we could drop the external tank down and we could hang it. We could hang it from the SRBs and dock it to the SRBs. The thing about that, though, and this is the one thing that will hose me, the one thing that really is that I never really figured out how to do with Kerbal is to have each SRB docked to the pad and then separate. How does that work? Kerbal doesn't, so like if you have two docking ports, right, on a vehicle, and you dock to something and both docking ports attached, one of them is your primary docking port and the other one is a secondary. And sometimes what Kerbal does is when you detach your primary docking port, the game logic makes your secondary docking port the primary, and it flips it. And in the application of this, you could very much cause a cracker strike. The whole thing could blow up on the pad. I'd have to go sit there and test it more to get it right. But yeah, that's the only real not theoretical. That's the only real unknown here with trying to reuse this thing. We can make this work. I could make it work. Yeah, nuclear more or less. I mean, cranes are a little bit different manner of articulation, nuclear. What you're trying to say is that, oh, you have software to make a human arm work. So theoretically, you have software to make a human leg work. I mean, yeah, but no, one's a leg and one's an arm. Cranes don't really work like the robotic arm does, dude. They don't. Different mechanics, if that makes any sense. But if you the software, yeah, if you write your software modular enough to be able to, you know, plug into any robotic, and I think we would if we did something like that. Yeah, I don't see why not. Was anything packed into the RCC section of the shuttle's nose cone, or was it hollow? It's hollow. RCC is actually quite thin, dude. Maybe about this thick. Like maybe 20 millimeter. Maybe. It's not very thick stuff. Cal controller to sequence undocking, Raymond, doesn't really end well. We tested that. The right way to do this would be to undo your secondary docking port and then undock primary, but even then, sometimes the game is like, oh, the secondary port's there, let me attach it for you. No. Now, I suppose with hybrid tech, we could probably make it work. But once again, that's a project for another day, dudes. We're going, let's go back over to Wonton. What does the cap say? Texas Tank Watchers. If we program an IK system nuclear, it should be doable across the board. Yeah, that shouldn't be that big of a deal. Guys, what I'm thinking with Wonton here is, I mean, that's a good, we did this as a good example to show analysis, but using Imahara might be a better idea. But then again, I said I was going to build everything. My brain's thinking about mission mode. Like in mission mode, you know, you got to be careful about development and stuff, right? In mission mode, you use what works, right? But the whole exercise here is to get back into the groove. Using the pad here, using this thing's pad would work, right? It would be good, but all this is going to do is using the pad would work, but all this is going to do is get you better at like doing integration over and over and over again. You're not actually going to build the damn thing. Mission mode is my rule set, Kai. That's the rule set that I played Kerbal. That I played in Kerbal for a long time. I linked it up in chat if you want to check it out. It's a very difficult rule set to play by. You really need to be on your game to do it. The whole purpose of building an end-to-end vehicle is showing you guys how analysis and stuff works, but it's also showing, I'm trying to get back into the groove. Using what's already here is not going to do that for us. Chad, I have a dumb question because I just rewatched the Space Shuttle launch and then the Starship launch right after it. Why does the Space Shuttle have a much greater smoke trail? Solids. The solid rocket boosters, Booth. Yeah, solid rocket boosters have a really puffy smoke trail. All of them do. It's just the smoke is a byproduct of the chemicals that they use in the solid rocket propellant. Yeah. If you have something like Raptor is going to leave a little bit of a smoke trail. It leaves a little bit of a dark smoke trail. It's really hard to see it though, because there's a bunch of reasons for this, dude. Long story short, it's just different fuel. Raptor is burning methane and oxygen, and the reason why you see some black soot coming out of Raptor engines from time to time is because the carbon that's in methane Methane is CH4, so it's 1 carbon, 4 hydrogen. You see some unburnt carbon come out the bottom, so sometimes you see like a black smoke trail coming out, but that's mostly because like a liquid fuel engine is much more efficient in its burn. Yeah, it's much more efficient. But that's not entirely true. But the combustion byproducts are, there's not as much coming out of a liquid fuel engine as there is a solid. Now, okay, here's the right way to say this. So solid rocket boosters are designed to pack a huge punch. They're designed to be very, very powerful, not the most efficient, but that doesn't mean you can't make an efficient SRB. If we're talking about like the space shuttle's boosters, for instance, space shuttle boosters are basically brute forcing that brick of a space plane into space. That's the idea. Just brute force, get that thing up there, right? That's the whole point. Because of this, they run extreme. They run kind of, the solid rocket mixture is kind of a little bit more on the fuel of the like, it's not a very efficient burn because you want to put out a lot of energy, so you get a lot of combustion byproducts. The SRB, quote unquote, the mixture runs fuel rich. That's not the right way to say it, but that's the idea. The way they pack it, you get a lot of combustion byproducts coming out because they're trying to squeeze as much energy out of the propellant as possible. And when you're trying to get a lot of characteristic energy out of your propellants instead of like straight efficiency, yeah, you get fuel byproducts. That happens. Same thing happens with kerosene engines. If you look at a Falcon 9 launch and you look at the trail coming out of the Merlin engines, it's bright yellow. That's because of all the combustion byproducts. It's all the extra stuff. Because a lot of engines run fuel rich. A lot of liquid fuel kerosene engines run fuel rich for temperature purposes and for energy purposes. But yeah, long story short, the short answer is it's different fuel. SRBs leave a lot of a trail because they're not very efficient because they're trying to make power. That's what SRBs are good for. They make a lot of power. You know, so it's not very efficient. Think like a big muscle car. Muscle cars don't get good fuel economy, but they make a ton of power, right? And you do get emissions from that. You compare that to an electric car. Like electric car it's different, using a different mechanical form of propulsion, right? Electric cars don't have any emissions, right? But does that necessarily mean that you can't make a fuel efficient car? No. Does that necessarily mean you can't make an electric vehicle that packs a punch? No. That's just what we use SRBs for. That's the best application for them in that regard. So this looks like I took Imahara and did a hybrid tech version of it. I made a hybrid tech version of the pad so it doesn't bend and break as much. Okay, I see what I was doing here. How are the new UPSs? Good as far as I can tell, Nova. Congratulations on paying your student loans off, dude. I have yet to do that. Nice to bring that comparison up. It's the same with chemical versus ion engines. Yeah. I mean, rockets are always a balance, or any form of spacecraft propulsion is always, right now, with our current understanding of it, it's always a balance. It's a balance between, you know, how fast you want to get there, and how efficient do you want to be. How much thrust you want to make versus how efficient you can be. Now, once again, that doesn't necessarily mean that you can't have an efficient high-thrust vehicle. The space shuttle engines are absurdly efficient for any chemical engine. The shuttle engines are one of the most efficient engines ever made, ever, period. The only thing more efficient is an RL-10, if you really want to know. And the shuttle engines make as much thrust as a Raptor engine does. That doesn't, with rockets, that doesn't mean you can't have your cake and eat it too. But there's trade-offs. The reason why the shuttle engines are so damn efficient is because they're using liquid hydrogen and liquid oxygen, which is extremely difficult propellants to manage. Using hydrogen is tough. It's hard to do, which is why you haven't seen like a hydrogen internal combustion engine. Could it be done? Yeah, sure. But managing hydrogen is not something for the everyday person to do. People have trouble with managing gasoline. Cue a video of the people filling up their diesel car with gasoline and vice versa. So, yeah. You don't want to do that with hydrogen. Hydrogen is a really volatile. Hey, Happy. So I've obviously been gone a while. What's new for your KSP? Wacky thingamabobs have you brute forced into existence? I actually took a break from KSP for a little while, Happy, especially after the fallout with what happened with KSP2. KSP2, they shuttered the design studio, they got rid of everybody, fired the whole development team, and then sold off the intellectual property. We have an idea of who owns it, but we don't know who does for sure. So I've been kind of just playing other things, dude. I've been trying to get back into playing KSP1, dude. For the longest time, I just didn't want to. I didn't want to play KSP. I really didn't. I didn't want to be involved with it. I didn't want to be a part of it. I don't want nothing to do with it. It took me a while to get over it. Get over that the Kerbal franchise is basically abandonware. That was a hard thing to reconcile, dude. This was the last project that I worked on, and what I'm trying to do is just get back into it. We came across a paper for building a rocket that was the successor to Saturn V and Saturn Nova. And enter Prometheus, right? So we worked on this. I got this thing working decently good enough. Sometimes it likes to blow up when you launch it. Sometimes it doesn't. It really depends. But yeah, this thing's a monster. It can move 280 tons into low Kerbin orbit in one shot. This is not sea launch. This would have been a ground launch system. It's about as big as the Sea Dragon, though. But yeah, what I've been doing, this is a smaller series that I've been going through about basically what it takes to make a small rocket, build out its launch complex and everything, and kind of go from there. But yeah, I haven't really been, I haven't mained Kerbal in a long time, dude. Long time. Now, that doesn't mean that there weren't some fun projects in between then and now. You'll like this one. This is a Rockwell Star Raker. I never really finished it because my old computer couldn't take it. It's 1,200 parts. But man, is this thing cool. Does the nose swing open? Yeah. Yeah, that's the payload bay. Isn't crossfeed worse than the parts for lag? It depends. But yes. Yeah. I mean, happy if you here. There you go. There's the one you want. It's I could make this better nowadays, dude. I could make a better one, but that's the idea. There's almost XH558. It's close. Prometheus is one of the biggest ones we've made, Pigeon. I usually don't make rockets that big. That's insane, specifically in the membrane. Yeah, happy. We also have this thing, the Lightning, with the over-under engines. It flies like it too. It's pretty cool. But I want to get back to building out rockets. I can get it. It's very easy to get locked, like get into KSP show and tell. Yeah, Garfield. It kind of, yeah, it is a Vulcan, but it's not. I could build better. There's an Arrow. The Arrow build came out really good. That's an Avro Arrow. It's pretty good. Little unstable with the anhedral wings, but yeah, it's pretty awesome, dude. That's a pretty fast plane, man. A real Vulcan bomber. I did not fit comfortably in the navigator seat. Nice. We've done all kinds of stuff, dude. I don't think, I'm trying to think, you know, when you left for a little while, dude. There's the Endurance. I don't know if you saw that thing. The Endurance is an Expanse style ship that we made. It has Kraken drives in it. And this thing can theoretically go faster than anything. We did test it out recently. I never put it into work. We tested it when I got my new computer, and it exploded. Yeah. So, probably need to work some kinks out with the design, but... Why don't you try really modded KSP? Because I don't want to. I also built the party hat.
Go and throttle up.
You want the party hat? See? Party hat. It came apart under acceleration, Enzo. Hey, Newell, tier 2, 6 months in advance, 34 months total. Thank you. Launch the party hat? It's SERV. Yeah, that's the, This was Chrysler's entry into the shuttle program, believe it or not. I think I don't need to tell you why they didn't do it. You know why a lot of supersonic jets use anhedral wings? It probably has to do with how supersonic shockwaves propagate, if I had to guess. All right, what I'm gonna do, guys, is build out a more finalized version of this, and then we'll kind of look at our numbers again and see if it makes it. So that fairing is actually pretty good. I don't mind that. Let's get rid of the dummy payload here. and I want to root part the fairing. So get rid of that. Get rid of that. Let's keep this low cost. What does this rocket need? Let's look at our avionics packages here. What do we have? We have the hex core. The hex core has some reaction wheel torque, but it has stability assist, prograde, retrograde, hold. Okay. And it's only 650 bucks. The Octo 1 has some probe core torque, but it just has straight stability assist. It's stability assist with no prograde, retrograde, hold. The Octo 2 is what I like using the most because it has prograde, retrograde, radial, normal, anti-normal. But we don't need radial, normal, anti-normal, hold. We don't need that. I think the hex is probably a good balance here. Prograde, retrograde, hold would be good for executing second stage burns for precision insertion. So here's what we're gonna do. Let's take a look at the fairing, right? My expectations for this were to use a 2-meter fairing. So you know what? I'll actually get rid of it. Now, just for now, I'll show you how to make a good one later. The aircraft tended to be too stable. A swept delta wing adds a significant dihedral effect. The anhedral offset that by adding instability. It basically couldn't roll. Yeah, I got you. Yeah. Hey, Zarek. You ever get into IRL rocketry like BPS space? I've been meaning to do that, but I find myself just getting into building automobiles. That's cool too, right? No, guys, I don't know. I'm just trying to get back into KSP and I just don't really want to use mods like right now. So we're looking for a 2-meter fairing, right? All right, let's get our avionics package and everything figured out. So what I'm going to do is I'm going to attach interstage nodes here. The fairing has a bunch of extra nodes that you can attach stuff to. And I want to attach my probe core to that. Now, why? Why do I want to do this? Well, actually, hold on. I'll tell you guys in a second. So let's finish building out Wonton, okay? Let's finish building it out and get a more fleshed out rocket design here. With all the kind of accoutrement that we want to make this a pretty good little robust launch vehicle. Let's do that. And then we'll think about what we want to do with the pad, okay? Maybe if we finalize out this design, it'll give us some clues to how we want to go about making the launch pad work. So, let's do this. First thing I want to do, I've decided what probe core I want for the application. Now remember, if you're playing in mission mode, you have cost, and I'll figure cost into this design. The hex core is good enough. It has stability assist, which means it'll hold, and then prograde and retrograde. That's good for doing burns. That's good for doing early game burns. You're not going anywhere crazy, so you don't... It's fine, as long as it has stability assist. Now, I do not like having wheel authority on my rockets. This probe core is equipped with a gyroscope, which every freaking probe core has one except for the Octo 2. The Octo 2 just has stability assist. There's no probe core torque. I wish these ones didn't have those, but I don't want a gyroscope in here. I don't want that wheel authority. I don't know why you have to pay less to have wheel authority, because these two cores that have it, and the smallest one doesn't, which is peculiar, but whatever. I don't want reaction wheel authority here. That's bad habit to get into. No rockets have gyroscopes on them, except if it's for navigation, but that's another story. None of them have, like, it's only certain types of satellites have a gyro stabilized assist. Only certain things do that. Like Falcon 9 doesn't have that. Atlas doesn't have that. Vulcan doesn't have nothing like that. They rely on thrusters to change course. And I'll get more into that in a second. Now, with the hex core, right? The HECS core. I took it out of the mainline stack, right? So I attached it to an interstage node. The reason why I did that is because I don't want my probe core to be sandwiched between my payload and my payload fairing. Normally, a rocket between its payload fairing ring and where the payload attaches would have a piece of equipment called a PAF, right? It's PAF for short. That stands for Payload Attachment Fitting. I know, very clever name. Payload Attachment Fitting attaches the payload to the rocket. Weird, huh? It's a structural adapter. And your avionics usually aren't structural. I don't like having integral avionics in my rocket's design. So I use the interstage nodes to stack this thing. And then what we'll do is
Discovery,
put a
go at
small decoupler up here, right? And the decoupler acts as my attachment fitting. And what I'm going to do is use gizmos in the game to move my probe core behind the attachment fitting. Now we have something that is much more realistic to how real stuff flies. Next thing I'm going to do is I made the payload attachment fitting, the ring, I made it a little bit smaller. The reason why I made it small is because, well, you don't want to make it the fairing's going to be out here, but PAFs usually are a smaller attachment point here. I'm doing that to save mass. But, I mean, honestly, you could probably put a big decoupler in here. But I like doing this way. Hey, Antisaint, 99 month resub. Thank you. I like doing this way, and the struts do end up making the mass of this whole mechanism a little bit more than what it would be if I just put a bigger decoupler. But I like doing this way because, I mean, straight up, dudes, it looks way better than just a payload attachment fitting just floating in 3D space. Sorry. It definitely does. You know what? I'm gonna redo that. I use 3x symmetry because that's the triangulation is usually the best way to get this done. And then I want to make sure that those are inside of the fairing like that. All right, cool. Now, once again, that is going to add mass. Your stream went to starting soon screen a couple of times. What? Car launch model rocket, yeah. I don't understand Sun Temple. All right. Cool. Now, the other thing we got to take into account here. All right. So, I really want my Wonton satellite to be able to tackle some early career mode stuff, right? So we're talking about just putting probes in different orbits, because that's usually what the game calls for in the early career mode, like when your rep is really low, right? So we're building this for purpose, right? That's our requirements. We want 1,000 kilos to low Kerbin orbit, and I want a stage that can stay up there for a little bit, and that's also good at doing precise orbits. Okay, so that means we need a couple more things here, okay? One of the things that we really need is batteries. Now, the probe core on board does have 10 electrical charge. That's okay, but we're gonna need a battery for this. I would like a battery in this application. So that's the reason why I spaced our payload attachment fitting the way that I did, because I bet we want to put a battery on there. That's 110 electrical charge should be able to last a good while. That should be good enough. Those batteries are 5 kilograms a pop. You know what? Let's make this nicer. These are 10 kilos, but I think that looks a lot better in this application, right? Yeah, the circular battery is a little bit heavier, but that's okay. Hey, freaking American, did you find your cord? Huh? If this is referring to prior troubleshooting tech things that I had to do, yeah, the setup is working fine. Okay, good. All right, nice. Last. Remember to make the electric wires heavier than the rocket. No, Blackness, I can't do that. I actually know how to do this correctly. Will you go to Joe's space shot launch? I don't know. That's a little ways off, Ador, from what I understand. Is the plan to include relay capabilities on these? No, not at all. Grabshark, this 5 kilograms should be negligible because of our analysis. Our analysis is a little bit over. I added some margin into the Delta V for this type of rocket, dude. So it should be fine. What I'm wondering is the way I want to build out the stage and everything for application, we might hit the upper echelon to those margins, but we'll see. We might have to end up extending Wonton to the size of Imahara, which, what was the point of making this in the first place? But hey, whatever, it's okay. You could repurpose the second stage as a relay satellite after the launch, or it not being useless. Or we could deorbit it because it's nothing. It's an inconsequential cost here. I don't know, maybe. I mean, that's added capability, Ator, but I would like to do Kerbal exploration and stuff too. That would be fun. Because remember, we got Kerbal constructs, guys. we could put runways wherever. We should write some mission mode rules on how to work with Kerbal constructs. But in order to do that, I'd have to kind of figure out what makes Kerbal constructs tick. So maybe in this engineering mode save, we'll go mess with it. We'll go mess around with exploring Kerbin and building different types of airplanes to do it. That would be cool, man, having runways all around or Kerbin. That'd be awesome. Just build airports, build a bunch of airports around Kerbal. We could make that part of mission mode. We could make it so you have to buy them and stuff. That'd be really neat. Because then we could put ground tracking stations down. Like actual ground tracking stations. And if, like, for instance, I have a capsule or something that comes down in the wrong spot, if we put the airports in the right places, it shouldn't be too far from anything. And we could leave planes and stuff there. Like we could leave recovery vehicles there. Stuff. I think that would be super cool. I actually like that idea a lot. Yeah, I know about Kerbal colonies. That's cool, man. It could be like an Aegina. Ator, what you're talking about, converting this into a relay satellite and making it like a target vehicle with Aegina, is scope creep. That's scope creep. That's not in our main requirements for the vehicle. This vehicle, 100 tons to low Kerbin or not 100, 1,000 kilos to low Kerbin orbit, and you need to build out the launch pad, and the launch pad needs to be reusable. Maybe if we switch eventually over to a design that, like if we build a crew capsule for it and everything, right? If we switched over to something like that and built that stuff out, then maybe maybe converting this into a target vehicle application could be useful. I could do it, but I don't want to do that right now. We could always change our payload attachment fitting and just attach a target vehicle array here and build the relay sat right to the payload attachment fitting like what Rocket Lab does. Rocket Lab's third stages, their Curie with the Curie engine, that's just a payload attachment fitting that's doing exactly what you're talking about. It's a third stage. It's a PAF that's been a payload attachment fitting that's been converted into a third stage that can also work as a satellite. Yeah, that capability is there, but we're not going to design that capability right now because that's not part of our baseline expectations. Rocket Lab didn't build that third stage right off the bat. They built it out of a need down the road. So if there's a need down the road, I could do the same thing here. It'd be pretty cool. Your idea isn't bad. I'm just not going to do it right now. Nostalgia trip. I remember when the KSP community first started using hydrofoils, and I made one to visit the North Pole. It took hours, but it was relaxing watching you and zooming 3 meters above the water. That's cool, Happy. I remember the hydrofoil craze. That was like in 2017, dude. I remember that. That was funny. Hey, Marcon, I haven't seen the beginning of this. Could you please summarize what your expectations are for the vehicle? There is a part 1, if you want to see it, where I broke down the analysis of building this vehicle out. Marcon, it's about 4 hours long. I filmed it on Tuesday. This is part 2. The short explanation, if you want a more detailed explanation into the analysis of the vehicle, go watch that VOD. But with this one, it's, oh, excuse me. With this one, it's 1,000 kilograms to low carbon orbit and a reusable launch facility. Not necessarily a reusable rocket just yet, but a reusable launch facility for the vehicle. I want to make a launch pad for it. I don't have them right now, Shy, but I can put them up. Exploring Kerbin in different ways was so much fun. Not just flying there in a rocket, but actually trekking there, either over land, water, or the air. So much more rewarding. For sure, Happy. Dude, Happy, I have a mod nowadays that I got while I was kind of on hiatus from KSP, called Kerbal Constructs. Kerbal Constructs basically lets you place down, like, you know, the tiles, right? Like a runway, or the LCC, or the launch pad, or the crawlerway, like a straight, I could build roads. We could make roads. Well, can't really make it go up a hill per se, but yeah. We could find a flat enough area and we could place down like the desert runway. Or we could place down like the island runway with its hangars and stuff. Remember how I wanted to explore Kerbin back in the day, but really didn't have a good way to do it, right? Kerbal Constructs would be a good way to do it. I could find a nice spot. We could go into the debug menu, subtract like the cost from how much money we have, and build an airfield and stuff. So we could put airports all around Kerbin. I think that'd be a super cool idea. Still better than Roadcraft. Dude, they had an update, Cherokee, and it added a bridge laying tank. A bridge laying tank. What? I don't... What? You have a game called Roadcraft, and you don't do... None of the vehicles are used for making roads. You could put operating costs for Kerbal Construct sites and structures. Flat fee would probably be better, so because I don't want an accountant for my mission mode save, dude. Mission mode accountant would probably ghost you too. Yeah, I could have done without that, but that's okay. All right, so we have a good thing going here. Let me, for a second, just detach the first stage, and I want to work on thrust vector controls, well, thruster control systems, so reaction controls. That's what I think we need to work on here. So if we want RCS, right? Because I don't want any probe core torque. I don't do that. That's lame. We don't do nothing like that. We need to look at thruster blocks and guys, I'm having nasty trouble focusing today. If you look at the date, I'm sure you could understand why. Yeah, just lock in, dude. Anyway, yeah, Nate, it's dude, I don't want to talk about it, homie. Yeah, I'm having trouble focusing, dude. We'll just leave it at that, man. All right, thrusters. Okay. All right, so we need to figure out what kind of thruster block we need, and we need to figure out fuel. Now, a stage like this, even with 1,000 kilos of payload up on the front, or 2,200 pounds, is still, you're not going to need a big reaction control thruster. What these thrusters are basically designed to do is basically steer the stage in a different direction to get ready for an engine burn or an engine firing. Pretty straightforward stuff. That's not a big deal. So now what a lot of people don't know is that, here, let's go look at Atlas Centaur upper stage. All right, so let's find a picture of a Centaur 3. That's a Centaur 3 right there. Centaur 3 is the upper stage that Atlas 5 uses. Atlas 2 uses Centaur 2, and Atlas Centaur uses Centaur 1. Vulcan, ULA's next generation rocket, uses Centaur 5. They skipped 4 because ULA doesn't like 4. I'm serious. They're like, yeah, we don't like that number. So, take a look. There are thruster blocks on the bottom of the Centaur stage. Now, some of these are used for tank ullage, but one of these tanks is a monopropellant tank. It's that one over there. And it uses the Centaur 3 has a reaction control system on it. They're little mini thrusters. You could see them. They're right there, and they have the red caps. Now, there is 2 caps of 2 thrusters on at 90 and 180. There's a cap of 2 thrusters there, and then opposite of it is the other. It has 2 thrusters over there, and then on the proverbial sides, so to speak, you have a thruster block of 3. The thruster block of 3 has a thruster pointed that way, a thruster pointed that way, and then a thruster pointed straight back. It has the plugs on it, so it's kind of hard to see them. But yeah, they're right there. The idea is that you have pitch, yaw, roll, but you also have forward thrust. So the thruster blocks kind of, we could always sit there and just mess with these things until it's right, but or mess with those guys until it's right. If you want to see how ULA's works, it's like this. This is just for visual representation, guys. I don't think we need to do this way, but I'm just showing you how Centaur's thrusters work. All right, so it has clusters of thrusters that look like that. Yes, clusters of thrusters. We love clusters of thrusters here, okay? And then in 2 times symmetry, you have a set of thrusters that look like this, that point straight back. The idea is that you have, with this thruster configuration, you have pitch, yaw, and roll, and then a forward translation. So the Centaur can go forward, but the Centaur can't go backwards, if that makes any sense. So that's how Centaur works. Falcon 9 actually has something like this too. But I do believe that Centaur is using monopropellant with a catalyst. So they use monoprop. Falcon 9 uses, well, Falcon 9 technically uses monopropellant as well, but it's the cold gas nitrogen thrusters. The same kind of ones that are on the Falcon 9 first stage. The second stage has those too, to be able to spin around on orbit. So you, for basically heading control when your rocket engine isn't firing. That is interesting, thruster pack. Why does RCS use hypergolics usually? Monoprop, I feel so used. Yeah, Dan, yeah, me too. Sorry, I gotta ask a bunch of questions all at once. That is an interesting thruster pack. Why does RCS use hypergolics usually? Graham, you'd use hypergolics. I mean, even monopropellant is using hydrazine, which is a component to a hypergolic. They use that because it's stable. It's stable on orbit for a long period of time. Hypergolics don't boil off. Monomethylhydrazine and dinitrogen tetroxide, or Aerozine 50, which is a kind of evolution of hydrazine, and a monopropellant catalyst. Those propellants don't boil off. They're stable for very long periods of time. Yeah. That is the reason why the Apollo LEM uses NTO and MMH. That's the reason why they did that. That's the reason why Apollo's service module is using the same exact propellant. That's the reason why the space shuttle's orbiter maneuvering pods and reaction control systems use all of that. Because hydrazine, monomethylhydrazine or unsymmetrical dimethylhydrazine and nitrogen tetroxide are stable for very long periods of time up there. The other thing is that with a hypergolic system, right? Even Dragon uses NTO and MMH. It's not like one of those legacy systems, right? Dragon uses it. That's what Dragon's thrusters are. Starline are the same thing, only their thrusters like to pop. Anyway, the reason why they do that is because you are afforded a much simpler engine design. Dude, a hypergolic thruster, you want to see one? I'll show you. I'll show you a Draco thruster. So this is right there. There it is. This is off of a Teslarati article. Way to go, Chrome. Keep up the bad work. All right, so see that? Look at how simple that thing is. It is not complicated, man. It is a combustion chamber, a throat, and a nozzle. Now keep in mind the nozzle is cut in a certain direction because it's designed to be built into the side of the capsule, right? This is the skin of the Dragon capsule. Yes, that does things to how the thrust gets propagated out of the system, but it's not that big of a, like, yeah, it's still rocket engines pretty good. Okay, so the reason why is because the thrusters are built into the side of Dragon. Like that. See that? Now, if you have one of these on opposite sides, if the thrusters are basically all symmetrical to each other, you would get a little bit of cosine thrust. It would give you a little bit of a moment of inertia that would affect rates, that would affect your YPR rates, if it wasn't completely symmetrical. If the thrusters are symmetrical, then whatever, it ain't no thing. That's for real life, though. That's not for KSP, guys. Oh, hey, come back. So, it's super simple, right? It's nothing, guys. There's nothing here. That's a rocket engine. That's a rocket engine that works. You have two injectors. You have a fuel injector and then an oxidizer injector that are angled from each other, right? Note that one of them is straight up and the other one's at an angle. The reason why is so you get what's called propellant impingement or commodity impingement in the combustion chamber. You want your propellants you want your liquid fuel and oxidizer to cross paths. That's true in any type of rocket engine injection system. You need them to cross paths. Basically, they cross paths like this, they mix better. Right? So one of them is teed off at 45 degrees and the other one's straight on. One's for NTO, the other's for MMH. These are fuel injectors. They're a space age fuel injector. Similar to a fuel injector on an automobile. It's the same thing. It's just an aerospace version of it. So these ones are actuated. If you look at all the wires right here, that's the wiring harness for a Draco thruster. They're actuated by electronic control, right? And that's why if you've ever seen videos from inside of Dragon from like Inspiration 4 or Polaris Dawn, when the thrusters are firing it, you hear a ticking noise, because that all you're really hearing is the sound of the solenoids opening and closing. Because where the rocket engine is, you hear a little thump, but you're not going to hear the rocket engine because it's outside. The sound doesn't propagate very well in the vacuum except through vibrations, right? But the ticking noise that you hear are the solenoids clicking open and closed, like a fuel injector on a car. It's an electronically actuated solenoid. It's a valve that's electronically controlled. It just opens and closes and opens and closes. Now, the other thing that makes these very simple is that, once again, you have hypergols, so nitrogen tetroxide and monomethyl hydrazine. When they hit each other, they explode. If they mix, they'll blow up. Those are weird forever chemicals, and when they hit, the way they chemically combine causes combustion. Very simple. The other thing is that with a Draco thruster, you don't need a turbo pump. You don't need a turbo pump, you don't need a gas generator, you don't need any of that stuff. These lines are pressurized, just like a fuel injection rail is on a car. Same thing. They're pressurized lines. Now, how is it pressurized? In a car, it's pressurized by an electronic fuel pump. You don't need to do that. That's too complicated. Too heavy. How they work on Dragon, how they worked on the space shuttle, how they work on Starliner, the Apollo CSM is that they have helium tanks inside of Dragon. They're helium tanks in a COPV, right? And that's the helium tanks are pneumatically attached to the NTO and MMH tanks, okay? And inside of the NTO and MMH tanks are what's called a fuel bladder, okay? The fuel bladder is like if you had a pressure vessel and you had a balloon and... Raptor side chat. Raptor side chat's going. Chris B is around. A fuel bladder works basically like if you took a balloon and you inflated a balloon inside of a pressure vessel, inside of a tank, right? So what happens if you pumped in air between the balloon, between the outside of the balloon and the inside of the tank? Well, the gases will expand and it will force whatever's in the balloon out, right? That's what a fuel bladder does. The helium goes into the tank, pushes the fuel bladder for the NTO and the MMH, and it creates pressure in the lines. The pressure in the lines basically makes it so when the solenoid opens, you get stuff shooting out. You get propellant shooting out because the lines are pressurized. Mysterious ticking noise. Nice, Happy. Anyway, so Graham, these thrusters are hypergolic thrusters are used in spacecraft because it keeps thruster design simple, very simple. It's called a back pressure. It's called a pressure-fed hypergol. Pressure-fed hypergol. That's what it's called. Very simple stuff. Helium tank, fuel tank, oxidizer tank. Helium goes into the fuel and oxidizer tanks, squeezes the fuel out, pressurizes the lines, and then you have two electronic solenoids controlling your injection mechanism. Computer controls that. Makes thrust. Very simple. The rate of so RCS thrusters don't really turn, they don't really stay on, right? They tick. They go, right? The cool thing about RCS is that you can adjust the tick rate on RCS for your application. So if you want to make more thrust, you can make it tick faster. If you need higher TWR, but we learned from Starliner that you can't make it tick too fast. If you make it tick too fast, this stuff up here starts melting. The reason why is because, so the nozzle, if you look, you know what people are asking, what is the nozzle made out of? Well, the nozzle is made out of what is it? Molybdenum? No. Niobium, that's it. It's made out of a very interesting type of metal that likes to radiate heat. Because if you think about it, it's a rocket engine, and a rocket engine is working in the vacuum. In the vacuum, there's no way to shed heat. There's no way to get rid of it. So this thing has to absorb a crazy amount of heat, right? And what happens with these niobium? Yeah, what happens with this niobium, the nozzle and the combustion chamber and stuff, is that it glows. It's the same kind of stuff that the Merlin vacuum nozzle extension is made out of. And if you've watched a Falcon 9 with me, you see the second stage, it glows, the nozzle glows. That's what that does. It glowing is shedding the heat through light, believe it or not. It glowing is the cooling system because of that type of metal. These thrusters do that. So because you have essentially a passive cooling system, right? You know, you can only pulse the thruster so many times before this thing just will take too much heat. And if you can't convect heat and it radiates, if you can't convect heat and you get this thing too hot and it starts radiating heat, or it can't radiate heat fast enough, you'll start conducting it through the metal up here, and then all this up here melts, which is what happened to one of Starliner's thrusters. Yeah. Pulse them. The rate at which they pulse is called pulse width modulation. We learned all about that from Starliner. Hey Chief, 83-month resub. I've never really understand how helium can just push out propellant. Won't it dilute the propellant by mixing into it and change the way the propellant gets combusted? No. It never mixes with it. It uses a fuel bladder. So, I explained it a second ago, Marcon. I'm trying to think of a quicker way to do it. So a fuel bladder is basically an inflatable. It looks like an inflatable thing. Now, keep in mind, the aerospace ones don't look exactly like this. That's a fuel bladder, okay? So it's basically like a bag that you put fuel and oxidizer into. In aerospace applications, particularly in the context of hypergolic systems, the fuel bladder is inside of the pressure vessel. So you put that inside of a COPV, right? And then the neck right here is where, you know, at the COPV. And you have, the thing about it is that at the end of these kind of special type of bladder type COPVs, you have actually two lines. You have one line that on the end of the COPV that's designed to go into the bladder, right? And then the other one is just designed to go into the COPV. The helium goes into the one that goes into the COPV. And what that does is it uses pneumatic pressure to squeeze the bladder inside of the tank. And that makes pressure in the line. Are they resealable? Dragon has no problem reusing the fuel bladders yeah, of course they're resealable. How many times has Dragon been reused? 5-6 times on Endeavor? Yeah, of course of course it's reusable. When you're done, so when Dragon comes back down, what I would do is purge the fuel bladder so you don't go around breathing hypergolics, right? Purge that out with like nitrogen or helium or whatever, and then evac the helium out of the system. Knowing SpaceX, they probably have an evac line to pull all the helium out that they just plug something into. And I'll bet you they have a hypergolic purge system that they just plug nitrogen or something into, something non-reactive. Purge out the tank, purge out the helium, scavenge all the helium out of the system, put it back into the helium tanks, right? And then when Dragon is ready, they go through fuel reprocessing and start filling up the bladders again. It's part of Dragon's refurbishment. Yeah, you can absolutely reuse these. Sure, why not? What is this thread? So those aren't happy. Those aren't, those are helium tanks, but they're not bladder tanks. Those are inside of the stage. Helium is put inside of COPVs that are inside Falcon 9's fuel and oxidizer tanks to do a slightly different thing called tank ullage. Okay? Tank ullage is a pneumatic system that keeps the pressure constant inside of the fuel and oxidizer tanks to make sure that the liquid oxygen and RP1, in the case of Falcon, have good head pressure at the tank outlet, and primarily at your fuel and oxidizer impeller inlet points. Basically, you want to be pushing down on your liquid fuel and liquid oxygen going into the fuel pumps, going into the turbine impellers, and it's the fluid impeller, but turbine impellers the turbine, but you get the idea. The other thing is that in order to get a good constant feed, you need to keep the pressure the same. So as the fuel drains out of the stage, liquid fuel and oxygen, they drain out of the stage, they have valves that open up on these tanks, and the helium takes that spot. Why do they use helium? Lower mass. If you were using nitrogen is a higher atomic mass. That's more mass. That's going to screw your delta V. That's why they use helium. And the cool thing is that, with Falcon 9, they probably have helium scavenging systems. If I had to guess, they probably have a scavenging system on the drone ship. If I had to guess, I don't know that for sure, but I mean, yeah, why wouldn't you do that? If not on the drone ship, if on the processing stool that they put Falcon 9 on, I'll bet you they have a way to get that helium back out of the tanks to save it, because helium is hard to come by and it's expensive. Now, once again, those are helium tanks, those are COPVs, but the spacecraft is using helium for a slightly different thing. They're using helium as a pneumatic actuator instead of for like tank ullage. It also works, it almost works the same way as your pressure tank for your well water system. Yeah, something like that. I think well waters just use compressed air to squeeze the bladder, but I'm not sure. Yeah, here, Rook has that video. Oh, thanks for posting this, Ordon. Here, listen.
Right, as you can see, we are coming up on 15 seconds to our next circularization burn. So right now, we're at 578 kilometers apogee, 370 kilometers perigee. So you can see Dragon's oriented into the velocity vector. We're at perigee. It's going to burn. It started its burn now. And this is going to lower apogee now to equal perigee, and we'll be circularized around 370 kilometers. You can hear the Dracos firing in the background. These are our forward bulkhead Dracos. This is our primary way to create a delta V maneuver.
Change in velocity maneuver. We learned about that.
It almost sounds like an orchestra.
Yep. That ticking noise is just the solenoids on the Draco thrusters ticking open and closed. Same thing. Same thing as like a car's fuel injector. On a modern car, you open the engine bay, you hear ticking noise. I mean, one, your engine might be destroyed, but two, most of the time it's just the fuel injectors opening and closing. What's that, Noctralox? What's on your mind? Oh yeah, here's what that looks like from Dragon's nose cone. SpaceX got the goods, man. They have all this great footage. It's such a good teaching tool, dude. Look, there they go. That's what that looks like from outside the capsule. This is on the nose cone. Dragon has a nose cone that deploys, and when it deploys, SpaceX has a camera that's looking back at this. What do they burn? Monomethyl hydrazine and nitrogen tetroxide. Be last. So does Starship use excess gas from Raptor pressure to pressurize the tank back up? Yes. The Raptor engine has a tap-off system built into it. It's not called a tap-off, but each Raptor engine can. Okay. We got to get back into the dang stage design, but we'll get back to that in a second. So Raptor uses something called autogenous pressurization. Because Raptor engines are using a full flow stage combustion cycle, they have there's a tap-off system. Somewhere down the lines in Raptor's plumbing, you have a spot where you just have gaseous methane and gaseous oxygen, right? And what a Raptor engine does is, in the high pressure points of its plumbing, it taps off that, and then you have gaseous methane and gaseous oxygen go into pneumatic lines, and they go up and they repress the tanks. That's an idea from the shuttle program, believe it or not. The space shuttle engines do that. That's why if you look at a picture of the shuttle external tank, the external tank has these weird like lines going up the side. See those things right there? This one is pretty straightforward. That's your oxidizer line because your oxygen tank is up at the top. The hydrogen line is right there. But if you look, there's a pneumatic line that goes right here and it goes up the side of the external tank. The hydrogen gaseous line goes into the top of the hydrogen tank, and the oxygen gaseous line goes all the way up into the very nose cone of the oxygen tank, to the very top. They're using gas from the engines. The Raptors have a tap-off built into them. Starship does the same thing. Now, there's a couple of different reasons why did Starship use it? Did Starship use it because it wants to be like the space shuttle? No. The reason why the shuttle used this, Grim, is because with this design, you're getting rid of your external tank. You need a new ET every time, right? You need a new external tank, right? They wanted to make the external tank as simple as possible. The external tank is quite actually what the name suggests. It is a hydrogen tank and an oxygen tank joined together at the top here, or in the middle, with what's called an intertank. It's just an external tank. Now, remember what I just said about Falcon 9. Falcon 9 has helium tanks inside for ullage purposes. NASA, when they were designing this, they didn't want to put extra tanks in here because you want your external tank to be theoretically as simple as possible because you're not getting it back. So what they did, what the engineers and designers came up with, is taking all of the stuff that you'd use to keep the tanks pressurized and putting as much of that into the orbiter as they could. And the best way to do that is to have your rocket engines have a gas tap off that repressurizes the tanks. It's called autogenous pressurization. That was their way of making the external tank as simple as possible. It is quite actually just a bunch of pipes and tanks. That's it. And a little bit of wiring on board because the wire harness for the tank has to include the sensors for the SRBs and whatnot. That, you know, that's kind of important. There, if you look, so think about this for a second. The shuttle's forward bipod strut attaches here and here, right? Let's talk wiring for a second. Let's talk avionics. There's no wires going up that bipod strut. Nope. But look right there. See this little thing next to the AP lines? That little guy? That is carrying the wire harness to the SRB forward attachment points. The SRBs they have computers on them and stuff. They have some avionics. The reason why they have that is because they got to deploy the parachutes, got to deploy the nose cones. They have firing pins on, they have separator pins on them, etc., etc. You know, it is computer controlled to an extent, because even after the SRBs separate, they still have to, like I said, they got to pop their chutes, jettison the nose cone, jettison the nozzle. The nozzles on the SRBs is one-time use because it's ablative. They made the SRB nozzles out of heat shields. It's made out of heat shield because that is that's the only way to keep what comes out of there, keep that nozzle nice and cool. So there's still some automation to the SRBs even after they're separated. Right there is carrying the wire harness from the SRBs. The SRBs are wired through they're wired through the forward attachment strut, and then the harness comes down here, right? The harness comes down and it attaches via these parts of the umbilicals. See what I'm talking about? Right, and this is what plugs back into the shuttle. Look, dudes, all I'm saying is that there's a reason why SLS's main propulsion system, the MPS, on SLS is complicated. There's one of your reasons. The wire harness from the core stage has to go from the SRBs, right? Like, where does it go? It has to go up from there, right? You have to make the harness go up instead of down. But your MPS, it still has to control all this stuff, right? Now, don't get me wrong. They probably figured out a way to make the whole harness go up. But still, the shuttle's engine section is a lot more complicated than just having 3 engines in the back. There's a lot of different things going on back there, including carrying the freaking wire harness. Because how else are you going to do that? Seriously. What, are you going to make the wires go through here? You're going to have to plug the shuttle in right at the hottest part of the thermal protection system? That's probably not wise. Right? The nose cone, the bipod strut is up by the nose. Nose is one of the hottest parts of the shuttle. You're not doing that, right? That's not happening. So they made the wire harness go through the umbilicals on the back of the shuttle, right? So the wire harness, the entire wire harness for the external tank actually goes down, and then it goes into the shuttle, and then it goes to the shuttle's computers that are up in the nose. So it kind of loop-de-loops, because how else are you going to do this? Right? You're going to put, you know, maybe you have like another door or something up here. You're going to put more doors on the shuttle. That's more mass. Use the doors you already have, because wires are pretty dang light. They're not too bad. comparatively to putting more mechanical systems into your shuttle, right? So that's what they came up with. Now, that's why the shuttle did it. Starship does this for a different reason. Starship does this for a different reason because on Mars you're not getting helium. you're not getting helium at all. So Starship uses autogenous pressurization because if you were using helium for your ullage, you're not finding that on Mars. Now, like I said, maybe they could scavenge it from Starship, but that means now you need a helium scavenging system built into your Starship design, and that complicates things. What you might as well do is use autogenous pressurization, and then instead of building a scavenging system, you work on with Starship, you work on in situ resource utilization. Because with Starship, you use methane and oxygen. So you have CH4, carbon, hydrogen, and then liquid oxygen. So oxygen. So you have carbon, hydrogen, and oxygen. Those are three things that are pretty readily accessible on the surface of Mars. Helium is not. Heck, helium's hard to find on Earth, for what it's worth. Wires of light. You sure about that? You sure about that? Well, if you take them into the if you take the mass of your wires into account in your finalized design element, then yeah, they're actually not too bad. Probably about 1,500 pounds or so for a space station module. What are the tolerances for the high-low pressure that could be for autogenous pressurization to work? Can it happen that the tank gets over or under pressurized? Mark on, there's check valves. Watch super heavy. See the flame? Actually, over here, that far right screen is probably better. Look, if you look at that footage, when super heavy's coming in, it has flames coming out the side, right? See it over there? See the flames coming out the side? Check valves for your AP system. Yep. There are check valves if the pressure, I believe it's mechanical. I don't believe it's computer controlled. It might be computer controlled. I don't know. I'm not really sure how those work. All I know is that if the tank starts to overpress, it'll open up the umbilical valves and it'll just shoot out the side. That's why during Flight 5, there's a lot of flames. Actually, any booster catch, there's a lot of flames coming out the side because the check valves are shooting out gaseous methane and gaseous oxygen out the side of the booster, and the booster is really, really toasty because where it just came from through reentry, and super heavy tanks the reentry, so it's quite hot when it comes in to the point where the bottom of super heavy glows, right? We haven't seen that in a little while. Haven't seen that since Flight 8, but right, the bottom of super heavy comes in looking like a pepperoni pizza, you know? So the booster's hot, and you're shooting out gaseous methane and gaseous oxygen, and it finds a source of ignition, and that's why you see flames coming out the side. Those are check valves. Starship has them too. And I am sure, at some point, when we see a Starship landing up close again, or we see one come back down and get caught, it'll do the same thing. It'll shoot it out the sides. Check valves, so you don't do that. What kind of waves can go through plasma? Obviously not radio, but what can? I don't know, nuclear. I have no idea. But yeah, good QA. I didn't realize you guys were this interested in extra exoatmospheric control systems for rockets, but yeah, there you go. Good stuff. So how long until stage 0 is needed? What? Why would you? Huh? What are you talking about? What are you talking about, fool? Excellent explanation. Thank you. No problem, Rarest. Elon calls the pad and tower stage 0. Yeah, Hellfish, I don't understand why you wouldn't want stage 0. Why would SpaceX be looking to remove stage 0 from their design? Oh, that's really nice, Oregon. Oh, nice. Oh, let me see this. Mars landing, maybe? Sorry, guys. I lost track of the conversation, dudes. The shuttle thing is kind of distracting me, but once again, I'm having trouble focusing today. Why? So are you talking about like remove stage 0 in the case of like a Starship landing? Yeah, I mean, I think at least in the interim time, SpaceX will just work with the catch pins for Starship, but eventually Starship is going to need landing legs for landing on Mars. Is that what you're getting at? Yeah, Denny, I'm glad you like it. I mean, we're a little light on the Kerbal gameplay side right now, dude, but if you guys like it, I'm here. I'm talking about in the context of airline tempo. I don't think they'd get rid of stage 0. Getting rid of stage 0 to Starship would be like saying, you know, I want my airplanes to run faster so we don't need a runway. How rapid reuse for a rocket translates from an airplane to rocket style stuff, at least in the context of Starship, Hellfish. And keep in mind, this is very much my opinion. The chopsticks are your runway. That's your runway. You take off and land there, right? Now, I don't think they'd ever get rid of that. Now, Starship, you know, Starship does need to land on an unprepared surface at some point. So Starships with landing legs will probably be a thing sometime soon, which is why I don't really get catching the ship if you're looking to, if your stakeholder expectations are looking to make a transport system to Mars. But I do believe that SpaceX made a trade-off there. I think the initial versions of Starship they're going to catch because it's easier to engineer catch pins than it is landing legs. Think about it. You got to lift the ship up. You got to put it on the pad. The catch pins are needed for integration purposes. And if they're needed for integration purposes, you might as well use them. Because that you already designed them, now you don't need to design landing legs. The other thing to take into account is that, well, that $17 billion contract from SpaceX the other day to buy the 50 megahertz of S-band spectrum frequency licenses, 50 megahertz frequency spectrum licenses. It's very clear that they're looking to fund Starship indefinitely via the Starlink program, particularly Starlink DTC, and only Starship can launch those. So, well, building out this transport system, they're building in the capability of sending it to Mars, right? It's very clear that their minimum viable product for Starship is a Starlink launching system. My guess is that the reason why they're doing that is because that way affords them the possibility of cash influx later when they go to design their landing legs. You don't need to design them now if you're doing Starlinks. Hey, Titan. Hey,
We
buddy.
have big exciting news.
Come on up here, Bubba's. What's up?
We went in the scary room where the Big Bang happened,
Yeah.
all by ourselves.
Oh, Taito.
We did it.
Titan, come here, bud. Come here. Come on up here. Get up here, my boy. No? He doesn't want to. He's my dog. Can you come on up here, bud? There we go. Nah, he's not into it right now.
Did you give him any like sleepy stuff or anything?
little bubbles. Is he feeling better? Hey.
It's gonna be a 6-month journey. This heartworm stuff is not a quick fix. But no, he didn't come to bug me at the end of work today, and then he seems sleepy, so it's just something.
Yeah. He's my bubbles.
He is a bubbles.
He's getting bored, guys. That's the thing. He gets bored and then he starts getting into trouble. You know, like.
Hasn't done anything horrible yet, though. Yeah.
Knock on wood. Yeah. We have to keep giving him medication to get rid of those heartworms. And then he'll be up and running around in the backyard again soon. But right now, he's kind of got to chill. You guys can't see it, and I don't have pupper cam hooked up right now. I have to rehook it up, but he's currently resting his head on my leg and looking up at me like this. Good boy. Good boy, guys. Hello. Hello.
Alright.
Come up here? Oh, nope. He wants to leave.
Alright. Making chicken for dinner, so.
Okay.
Love you.
Love you too. The behind the scenes camera doesn't show the floor, Raiden. You would have just seen Brimo's back. Like, he was down here. This is where his head was. You can't see it. Like, it's where dogs seem to know about cameras. Yeah, maybe. He'll be all right, guys. He's fine. Like, heartworms, just he coughs a lot, and the meds are. I think the meds are making him tired, like, because he just sits all day and does nothing, and that it's tough to see because I know he ain't that kind of dog. Titan likes to run around. That's his favorite thing to do. He loves to run. He loves to play fetch. He likes to go explore things. He loves sniffing things, and just, yeah. It's tough, dude. But hey, he's here. He's alive. Heartworms are curable, so that's good. You know, we got that going for us, which is nice. Anyway, Ordon, this shuttle component thing is quite cool. Who is this? Developed by Charles Martin. Oh, this is a USA paper, so this is legit. This is a real one. Yeah, Aqualex for sure. Yeah, that's really much it, dude. It kills me to just see him there doing nothing. And you know, like, he knows something's up. He just obviously can't rationalize that. He's a dog, but he knows something's wrong. Like you could tell he's like, why aren't we going outside, human? Why aren't we doing that? Remember, you know, I like doing that, right? Like, we should go do that. And I'm like, oh, I can't. He has to rest. With heartworms, he can't run around. He can't do strenuous activity. And it sucks because the dog's favorite thing to do is strenuous activity, dang it. We have a bunch of, Oglex, that's what we've been doing. We give him toys that make him use his noodle, small as it may be. Oh, there's your wire harness stuff that I was telling you about. See? Crossover and cable routing. See, the SRB's wire harness is carried through the external tank attachment point. The forward external tank attachment point. What do you mean, no zoomies? He gets zoomies, dude. And I'm like, I have to calm him down. We have to chill him out from zoomying, Or else he'll, yeah. This is a really, really awesome render of the upper, that's not the upper strut assembly. That's the lower strut assembly. Oh, yeah, no, yeah, whatever. It doesn't. Yeah, that's the other thing. Check this out. Look at all the wiring that's going through the raceway on the SRB. Because you guys got to remember, the SRBs, all the wiring from the SRB goes through the forward attachment point, right? Not the aft attachment points. The aft attachment points are mechanically there. They're mechanically there to keep the SRBs true, to keep them perfectly straight on the external tank. And they have a shock absorbing mechanism built in. You can't make, I mean, you can make wires go through that, but they didn't. So the SRBs have what's called a raceway going up the side, and that's super cool that this has pictures of it. There it is. There's all the cables. Now those cables are down there for the APU that's down here. Those are your separator motor igniters. Those are the explosive bolt separators for the aft attachment points. These are sensor and control wires for your thrust vector control systems. Sensoring for the APU that's back here. How the SRB gimbal mechanism worked is they had an auxiliary power unit down there, and the auxiliary power unit was using hydrazine. So if we see a kind of render of the aft section here, there's a bunch of stuff on it. Those are the pad attachment pins. Those are the frangible nuts. That's not exactly what I'm looking for. Ordon, this is super cool. I'm actually gonna take this and we're going to put it in the shuttle rocket research folder. There's your batteries. No, I don't think those are batteries. Never mind. Oh, there's a wire diagram. Oh, here you go. Here's all the stuff that's going on in the aft skirt of the shuttle SRBs. See, you have an auxiliary power unit that generates power for a hydraulic system with an accumulator, and the accumulator drives your thrust vector control systems. That's all the wiring that goes up and down the SRBs. It's carrying all the control and power systems for that. The overall cable routing is interesting. Yeah, Aqualex, it's a very, oh my goodness. Yeah, it's very interesting that they made the wiring go up the SRB and then into the external tank and then down the external tank into the back of the shuttle. I'm sure, dude, I am 100% sure that there is a very, 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 very good reason behind it. Nothing on the shuttle is done by accident. Yep, there's the APU turbine mechanism. So check this out. If I'm remembering this correctly, guys, this system uses it uses hydrazine. It takes monopropellant. It's a monopropellant thruster, but it's a monopropellant thruster that's shooting into a turbine to generate power. So they take hydrazine and they flow it through. It's pressurized. You have residual pressure in the tank. It's at high pressure, right? And yeah, see your fuel supply. Right, fuel supply flows into the APU, so the fuel supply is hydrazine. Hydrazine goes into the power mechanism. It's depressurized, like basically just like keyboard air. It's just pressurized in the tank, and they let it go, and I mean, the tank only needs, you only need enough hydrazine in there for about 2 minutes and 30 seconds of operation, right? It's only going to work when the SRBs are going. You don't need thrust vector control systems after the SRBs are separated, right? So these only, they don't need to last very long. So your hydrazine goes from here into a catalyst, and that catalyst reacts with the hydrazine and generates a ton of heat. And that heat, that heated hydrazine that goes through the catalyst drives the turbine. And the turbine drives basically a power takeoff. It drives a hydraulic pump. There you go. Now, the nutty thing about this, dudes. Now, I don't know if there's any hydraulic mechanics out there. The crazy thing about this is that your APU and fuel supply and hydraulic accumulators are double redundant. There's two of them. So if one breaks, you don't lose control of your SRB, right? The nutty part about this system, and this is mechanically controlled. This is not electronically controlled. Like there's a computer telling the system where to put the hydraulic fluid, but the double redundant APUs are can both drive both hydraulics. So one of these things can drive both, and the other one can drive both of them either. Both of them can drive this, right? You have two areas of hydraulic pressure going into a system. So if one breaks, the other one, they can operate too. One of these can operate too. Two of them can operate too. All in a singular system. That's hardcore, man. That's some really nutty hydraulics. Hydraulics get a little tricky when you're generating pressure from two spots, which is why, like, look, there's even a check valve filter, just like a hydraulic system on an excavator. See the manifold over here? Your manifolds are designed to work with each other. So like how a hydraulic usually works is you get pressure from one, you have pressure, and then you have a return, right? Getting pressure from two spots complicates this a little bit, but would you rather not steer the SRB? Steering the SRB is kind of important. Yeah, I don't know. There's, if we want to put the thinking noodle on, why would they do that? What are they trying to do? My mind is defaulting, Aqualux, the quick and kind of apparent reason why the SRB wiring is going to the top, and then into the external tank and down to the back of the shuttle. I know the reason. They can't. Yeah, I know exactly what the reason is, dude. Sorry, I had to think about it for a second. You can't put them down there with the aft struts. The aft struts on an SRB are designed to deal with the thermal expansion and contraction associated with cryogenic tanking. So hear me out. The SRBs are attached, the aft SRB attachment points are attached to the hydrogen tank, which contracts when you fill it up with hydrogen. It'll unplug your damn wires. The forward SRB attachment points are attached to the inner tank. Now, the inner tank does go through some thermal expansion and contraction, sure, but your forward attachment point is your primary structural load carrier. That's the primary load path of the SRBs gets dispersed through the forward point. Meaning, for the people that don't understand shuttles, the SRB is pushing the liquid oxygen tank and pulling the hydrogen tank in the shuttle up into space. Cool, huh? So yeah, you can't put it down there. if you plug the wires in and then you went to fill the external tank up with hydrogen, the external tank contracts, and those struts are designed to take into account the thermal expansion on the back of the vehicle. Can't put wires there because it moves. I mean, you could put a little flexi joint there, I suppose, if you want. But at that point, they must have thought, like, you put the wires in a spot where you're not going to have to deal with that as much. And you don't have to deal with it as much on the inner tank because the inner tank is not a fuel tank. Hey, Baron. 11-month resub. Is it possible to attach one more or two SRBs to the shuttle? Lev, I seem to recall a paper that I read in my travels of a shuttle with 3 SRBs. One is, so you have SRB, external tank, shuttle, and then 2 SRBs on the side. I don't know if I dreamt that or if it was a paper now that I'm thinking about it. Maybe. Hey, Maddie, what's going on? Where did you get these documents? Internet, baby. Find anything on there. You want the link for this one? I'll give you a link for this one if you want. Here, I'll post the link in chat. Yeah, they can't. They didn't want you. You don't want to put them down here. These aft struts are designed to flex. They have a flex joint built in. The other thing that I can think of, Aqualex, is that, well, the SRB's brains, so to speak, are up in the nose cone. The brains for it are in the nose cone. So that means the majority of electronic stuff is up here. So, you know, why make another wire harness that goes through here? This stuff has to talk to this stuff down here anyway. So, you know, you want the brains of the SRB hooked to the external tank, right? This raceway here does carry the mechanisms for the separation, right? And heaters and whatnot. It does carry that mechanism inside of it, but everything needs to talk to up here. The brains of the SRB are up in the cone. So you're running the wires up there anyway. Might as well run them through the forward point, right? It's a little more wiring for the external tank, but that simplifies your wiring on the SRB big time. Once again, it's always a trade-off. The trade-off here is that your external tank wiring gets a little more complicated, but remember, you can't run it through the aft strut anyway. The aft struts move. They move too much. Do you think all the engines on the new Starship booster will move? No, Yum Food, just the inner ring. There's no need to have 33 engine thrust vector control, dude. You don't need to do that. Yeah, look at that, huh? Yeah, look at that. $3,000 PSIG. You need a lot of power to turn an SRB nozzle. It's a lot of thrust coming out of the bottom of those things. Oh, this is so cool, Ordon. I love stuff like this. Yeah, Yum Food, I just don't really see the need for doing something like that. Anyway, let's get back into stage production, second stage thrust systems. Now, we could do this way. This is fine. I think the thruster blocks might be a little bit easier. But you know what? Now that I'm really looking at this, I don't mind this mechanism. I do want to change it up a little bit. Let's just take the engine and just move the engine back for a second here, so I can get at the thrusters a little bit better. The other thing I'm going to do is I'm going to take the entire stage and I'm going to turn it 45 degrees. Okay. And now what we're gonna do is make the exact same thruster block here. Of course, we're not in symmetry, huh? Okay. Now, the reason why I rotated the stage 45 degrees and then placed the thrusters is because I like working with the up-down axis. I like to, whatever I'm working on the vehicle, like, could we have just like taken a thruster and just put some thrusters there like that? Sure, we could have done that. That would have been just fine. This ensures precise placement because you're placing the thrusters on one of the world axis, right? Meaning, you see the green right there? Green's pointed straight up and down. That is aligned to the axis, well, we're plumb with gravity, right? You're parallel with the force of gravity. In real life, they do this with stages. They put them on a rotisserie, and if they need to work on them, they rotate it so it's easier to install components, like Falcon 9 landing legs. They rotate Falcon 9 to put the landing leg on it, right? They don't try to put it on at a weird 45-degree angle, right? I like this because this ensures precise placement. And it ensures that because we did it in 4x symmetry, that all of these are extremely precisely placed. So now I'm going to rotate the stage back. And when we do, there you go. We have our thruster blocks. Pretty cool, huh? Yeah, you don't need 4 thrusters to go for forward propulsion here, Nick. I don't want that. I don't want that in 4X. That's how Centaur does it. Centaur and Falcon 9 all do something like this. Now, these are monopropellant thrusters, guys, so we're gonna need a monoprop tank. Yeah, see, now we can attach the little balls to the back. Actually, because of mass concerns, I only want one. You only need one. That'll be fine. I don't really like how close that is to the engine. We might want to extend this just. Must be a male rocket. Oh, how can you tell? Balls. You can always do that, but then we're covering the thrusters. I don't like that. You know what? I might use this. I might use this because now it looks like my thrusters are mounted on the bars. I think that's kind of cool. It looks like we have a mounting point for them. I like that. Yeah, crude, childish, and always funny. All right, cool. This is pretty good. Hey, it's pretty good. Now, a couple of things here. lost focus again. Center of gravity, negligible. It's not gonna affect it too much, dude. Look, I'll show you. Like, look at the thrust. See, it's that tank is nothing, and it's pretty close to the central thrust axis. So yeah, the gimbal will be able to compensate for it, no problem. That's easy peasy. If we really wanted to be trick with this Nick Paw, we could take the engine and turn it a little bit. If you really wanted to get crazy, take the engine, turn it like that through the COM. If you really want to get nutty, but I don't want to do that. If you did that, you turned it through the center of mass, the stage would fly straight, but it would fly straight while it's pointed crooked in a different direction. You could do that, and then you could turn your control point up at the front, so your control point could be pointed this way, right? And your stage could be pointed that way, and your engine could be pointed that way. So it would look like a weird S, like your control point and your engine are pointed in the same way, but your tank's connecting them on a diagonal. You get the thing to fly straight. What do you think the space shuttle does? With its engines tilted like that? What do you think that does? Yeah. Just saying. Let's do that? Nah, I'm good. I'll let the thrust vector control systems deal with it. Nah, I'm all right. Why isn't the RCS put up on the front? Okay, Nova, good question. Let's attach an imaginary payload to this. Look at our center of gravity, all right? Now, with a second stage, right? The way we're kind of putting this all together, the second stage gets basically is not out of fuel, right? But there's not a lot of fuel left when you're on orbit, right? Not a lot of fuel left. The reason why ULA, SpaceX, Space Shuttle, even to an extent, the reason why the thrusters are on the very back of these things, right, is because it's easier to steer the stage, because in a conventional stage design, so Space Shuttle notwithstanding now, your center of gravity trends towards the payload, right? You got to be able to steer this thing with payload attached. These will give you the most effective control moment for the least amount of thrust. I.e., if I had my thrusters here, I would need a bigger thruster to get it to turn at the same rate as a small thruster that's further away. Leverage. It's just leverage, dude. You get a larger, yeah, exactly, Rockets. You get a larger what's called moment of inertia, MOI for short. MOI will affect your pitch, yaw, and roll. Higher moment of inertia means you can use a smaller thruster. A smaller thruster that's further away induces the same amount of moment of inertia as a bigger thruster that's closer. That's the right way to say it. I'm just gonna put that like that for a second. Let's go back and look at, I need to look at Imahara for a second. Could horizontal engine test stands work in KSP similar to McGregor? I know it's kind of a stupid idea. I was thinking about how the development of rocket engines do that. Yeah, sure, why not? You would have to develop an attachment point, Maddie, for your rocket engine, but yeah. Rocket engine reliability is not a thing in KSP because the engine's always reliable. It's never not gonna work unless you build a mod. Dude, that actually reminds me. Das, my buddy Das that works for NSF nowadays, right? He played a rule set of KSP where engine reliability gets better the more you fire the engine. So if you have an LVT-45, right? And if you built a test stand for it in game, right? And then did test firings with the engine over and over again, the mod takes the amount of runtime it has and stores it, and the runtime improves the rocket engine reliability. No, where's the beard? It's ablative. Don't worry, it'll grow back. It's called Scrap, and usually you use Crash as a simulator to test things out too. Scrap? That's awesome. Oh, dude, I like what I did with Imahara there. That's super cool. I'm stealing that. Dude, Imahara is such a good rocket. It's so, dude, I broke the mold for small sat launchers when we made this damn thing. So I put the SM6A service module in there to make it look like a payload attachment fitting. It's all fun and games until your parachute doesn't open because it isn't reliable or your antenna stops working. I'm stealing that. I'm stealing... Dude, I like Imahara. This is a good rocket, man. We did a good job with this damn thing. You know what? I'm lifting past ideas for this. We'll make, Wonton will basically be Imahara 2.0. Might that be something that you're interested in? I don't know why I used the docking port here. How much are docking ports? Docking ports are $800. How much are a decoupler? Oh. 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 Well, yeah, it looks pretty sweet though. I'm a fan of the worm logo. I like the worm logo too, man. Payload reintegration? I never designed Imahara for that, dude. That's the weird part. See, that looks like a PAF. That's cool, man. That's a trick design. I like that. And, you know, we'll make a lower cost version of it with the smaller port. But see, this makes it look like it's connected, but it's not. The docking port is connected right to the fairing. There we go. Now that looks like a payload attachment fitting. That's cool. I like that. Actually, if we really wanted to make it look like a PAF, we'd put the shroud on it. That's what a payload attachment fitting looks like. And oftentimes the avionics, the brains for the rocket, is underneath the payload attachment fitting like this. And the fairing goes around it like that. That's what a real rocket looks like. See, you could use stock. Why do we need mod parts? You can use stock parts in KSP and make it look like the real thing. PAFs usually cover up all your avionics, so your avionics don't bake in the sunlight. Just saying. Had to spend a few dollars on tires for the crane today. $14,966 for new tires for your crane. Okay. You're so right. Maybe just realism. Do real rockets use explosive bolts to release their payloads? Some of them do. But why would you do that, Nuclear? Do you want an explosive going off next to your payload? Payloads are usually expensive. Don't need explosions going off next to them. In fact, they put them up at the top to make sure that that doesn't happen. They're usually a mechanical clamp that's electronically actuated. At least that's what they are nowadays. And the separation mechanism is a spring. So basically they have a bunch of springs, right? And the payload has a flange, and then the payload attachment has a flange, right? And they force them together, and then there's a clamp that holds them together, and two electronic solenoids, or an electronic solenoid clicks the clamps open, the spring's decompressed, and it shoots the satellite off. Simple. Doesn't need to be complicated. The spring's decompressing is enough force to push the satellite away from the stage. I like that. That's super cool. All right, now look, right here, 2800. We have a very, very, very good stage here. This is really good, and it's trick, and it looks like this is how real stages go together, dudes. It's like this. This is what they do. I'd like it all. I want an all white thing. I mean, you know what? We could leave the checkers on it. The checkers are cool. Hey, Rob Cobb. What's up, man? 70-month resub. Coming to Boston next week. What's one thing I can't miss? Oh. What? Well, Rob, what do you like? There's all kinds of things to do. It really just depends, because, you know, the first thing that popped in my head is go to a baseball game at Fenway. But if you don't like sports, that's not really it. And if you're on a budget, that's not really going to work. Like a Jack in the Box. That's right, Bill. Yeah. Bill, sorry for the silly question, but are you trying to reuse the first stage at all, or is it expendable? Expendable initially. When I made a model rocket in high school with a payload, we built the payload around a CO2 canister and a spring-loaded punch on a timer to push the payload out. Don't think it would work. It would work in space, though. Rob, there's a lot of stuff to do in Boston. That's one of the reasons why I like it. Yeah, Aqualex, you know, scrap, that could be cool. I don't like random failures because there's no random failures in rocketry. It's always, you can always trace it back to a certain failure point. That's the big thing. Rockets don't fail randomly. It's not like the movies, you know, where it's like, oh, this part just randomly failed. No. If a part fails in rocketry, it's because your analysis wasn't good enough. You can trace the fault tree. There's no random accidents in rocketry. Everything happens for a reason. Everything happens in physics for a reason, right? So I didn't like, oh, random failures, dude. But yeah, I would, Aqualex, you know what would be cool? Not necessarily a random failure, but more test time with the rocket engine improves the performance of the rocket engine. That would be cool. Because, yeah, I don't like random failures. Rocket failures don't happen for no reason. They happen for a reason. And it's most likely, if it's, you know, if it's design or QA oriented or something, you can figure out why it did it so it never happens again. Fast. I'm looking at the Delta V map trying to plan Delta V from getting to Duna orbit. Getting from Duna to orbit. 2.5. You're getting from Duna to Duna orbit. You're on the surface of Duna, trying to get to orbit, 1450. Or someone drops it, yeah, and so yeah, there's that. Sorry, I'm losing my train of thought really easily today. Yeah, it's hard to focus, dude. I'm trying. I'm giving it my best. Jackal, I don't want to talk about it, man. I shouldn't have even brought it up. All right, so I have my I-beams here. I placed 2 I-beams, and I'm looking at the width right here in my engineer's report. It says where our width is at 2 meters. So I put the 2 I-beams together. These I-beams, the small ones, they're 1.5 meters long. So if I take another one and kind of gizmo it into the right spot, you can make a beam that's 2 meters long. I said this thing wanted a 2 meter, I wanted a 2 meter fairing in my expectations for the vehicle. So what I'm going to do is I need to build a fairing to that width. Now, what do? Do we eyeball it? Oh, then I try to get the fairing. I go to get it to try and line up. No. Here's a cool building trick that you can do here, guys. So take one of these cubic octag struts, okay? And then take another one, and then surface attach it to the side, okay? Right? And now move it away a little bit, and then take a strut and connect it. And then make sure that your strut is set to, make sure you hit F to go to absolute for the offset, and then snap both of those to the absolute axis. And the cool thing about struts is that the actual strut part of your strut mechanism is not it's not collidable. Like, see how I'm putting my mouse through it and it's not highlighting anything, but if I put my mouse over the I-beam, it highlights something. That's the collider. There's no collision here. If I tried to make the fairing, right, and we use the I-beam as our measurement, right, the fairing wouldn't let me build it because it'd be like, no, I can't build a fairing here. There's an I-beam in the way. But these things, I call them Tessa rulers, right? Go like this. We wanted a 2 meter wide fairing for wonton, right? So we build it, and then if we turn the camera straight up and down, and we hit C to take toggle snap off, look at that. There's a 2 meter fairing. See, I can use that as a ruler. Actually, dudes, I don't know if we need a 2 meter fairing. Are there any downsides to saving a copy of a fairing section to reuse for later rockets? I don't think so. Are you going to do space news today? Well, Ozzy, we have, yeah, in some way, shape, or form, we have the new Centaur Lima launch. It scrubbed yesterday. That's at 8. So, yeah, we'll probably do some space news. What mods do you recommend for KSP1? There's all kinds of good stuff out there, Lord. I use a bunch of visual mods. Here, let me show you. I'll show you my mod list, dude. It's in Twitch chat. KSP1 mods. There you go. It popped up over there in Twitch chat. Anything for after hours, maybe a specific finished car game. I think I'm just gonna do Kerbal in the launch today, dude. DJ mod packs for KSP. Glad to be back. Thanks for saying that. Yeah. All right, so 1.5, 1.6, 1.7, 1.8. I'm actually thinking a 1.8 meter fairing might be better. Oh, 1.8 meter fairing doesn't align. I can't snap it into position. So 1.9. Yeah, the fairing doesn't need to be this big. That's a little wide for a rocket of this size. I saw 2 meter fairing and I thought that's what we need, but right there is good. Now, we could probably go one more. Yeah. Let's delete the fairing, build another one. Once again, we can go straight up and down and we can get a perfect alignment here. This will probably end up being a 1.7 or 1.8 meter fairing. Yeah, that's pretty good. Clamshell, we want a clamshell deploy, and I want to increase my ejector force here. Set it to 500 to get the fairings to separate. I also want to just edit it real quick. There we go. Now that's a fairing. Perfect. Now, what I want to do is make it so this thing can take into account 2.25. Can it fit the 2.25 in there? Sure. The reason why is because Wonton Rocket, I changed a couple of stakeholder expectations here while we're going through our design. Guys, I want to take Wonton and basically make it a version 2.0 of the Imahara rocket. Now, that's okay. We haven't designed a pad and all this other stuff. It's easier to change expectations here as long as they're clearly defined. But you really should make up your mind sooner rather than later. I know exactly what I want to do here, based off of looking at Imahara. The reason why I came up with the original specifications for this vehicle, and I mean, keep in mind, we're going to have to do analysis on this again. The reason why we're gonna have to remove the shroud, or it shows up in staging. I don't want to do that. The reason why I came up with that is because I frankly forgot what the payload capacity of Imahara was, and I was trying to nail Imahara's design specifications off the top of my head. I completely forgot how a vehicle that I made for mission mode works. So what I'm going to do is, my building technique has gotten a little bit better since building the original Imahara, so we're going to build a better version of it. So Wonton is basically going to be the Imahara 2.0 rocket. Now that's a nice fairing there. So I'm changing up my payload specifications. Now, here's the thing. You're changing your stakeholder expectations. We switched to a 2-ton payload capacity, right? A 2-ton payload capacity and a 1.7 meter fairing instead of a 1-ton payload capacity and a 2 meter fairing, okay? So we decreased fairing width and we increased our payload capacity. Doing that is basically it basically invalidates the original flight test. There's no point in, like, I can tell you that right now, that this with 2 tons up at the top is not making it into space. It barely made it with 1100. So it's definitely not making it now. So we're gonna have to redesign and do more analysis here. We're gonna have to redesign and reevaluate, especially the first stage. I do believe our second stage still has the Delta V that we're looking for here. There we go. Our second stage has 1507. It was 2200 with 1100 kilos. Now it's 2250 kilos, and it's taking a good amount of delta V off. We lost 700 meters a second delta V. Once again, gonna have to do our analysis again. So what we could do here is extend our second stage. We could make our second stage bigger, or we could make the first stage bigger. Isn't this what happened with Starship? Tons of redesigns from ITS to BFR to 2018 to Starship. Yeah, Archie. Yeah, they made a lot of, they redesigned a lot of things with Starship. But they changed the expectations of the vehicle. They redesigned and redefined requirements. Or they redefined requirements and redesigned a lot of things before they even started making Starship. Right? Heck, SpaceX started making carbon fiber domes for Starship. They started doing that originally, right? And they realized that a carbon fiber, 12-meter design is not going to get you very far. That's not mass producible, and Starship needs to be mass producible. That's why they switched to steel. That was the last big stakeholder expectation change. That was the last big design change, because their stakeholder expectations, part of what Starship needs to do is it needs to be able to be mass producible. You need to be able to make as many of these things as possible, which is why you see SpaceX build stuff like the Gigabays at Roberts Road at the Cape, and Boca Chica, they're building a Gigabay there too. Right? Because mass production is a stakeholder expectation for Starship. That's not necessarily a stakeholder expectation with other vehicles. It definitely wasn't with the space shuttle. It's definitely not with Atlas. Right? Factory production output is a part of Starship's design, and that's important to understand. I wonder if they'd be able to dial in the manufacturing and switch back to carbon composites at some point. I doubt it. Well, remember, the more you change stuff like that, the further you get into a project, if you're changing your goals, okay. My brain went into overdrive for a second. The further you are into a project, the more difficult it is to change your stakeholder expectations. You don't want to build something and then, get halfway through actually making it and then change your mind. It's important to have expectations and vehicle requirements set. At least the real generalized stuff. You can get into more, granular requirements as you work on individual systems for the vehicle. But the overall requirements for the vehicle, like payload capacity, that's really important to baseline that in the entire vehicle design, and then back it up with analysis. In Kerbal, like I said, I have to redo the analysis and delta V numbers for the stage. We got to redo it all, right? In Kerbal, if we weren't playing like via mission mode rules or just kind of playing, a hardcore play set here, I would just put it out on the pad and fire it off and see if it works, right? But I like showing you guys. I want to get into a habit of showing you guys how this all goes together, so it can teach a new generation of people about spaceflight. There's a lot of older viewers here that watch the stream that know all this already. But we do have a lot of new faces in here. And we do have a lot of people that have never seen me play Kerbal live. This is how I do it. We have steady design requirements. We have stakeholder expectations. We have design reviews. We chit-chat about different ways to do things, and we find the best ways that's suited to our needs to do things. I like to tell people I don't play Kerbal Space Program. I don't just play it. I engineer space programs in this. And I use it as a teaching tool to show people how the people that do it for real do it. Okay, Bree, I'll be down in a little bit. Thank you. Did you just call us old? No. When I said old, I meant the more mature viewers on the. Yeah, the more tenured viewers. Jindex, thank you for the 68 months. I appreciate it. Hey Parchin, what's going on? Has the last Atlas been manufactured yet? No, but close, Jeff. All right. So, this is all fine and dandy. This is good. I like this. This is really nice. We got a nice stage. We got batteries. We have a payload attachment fitting. I redesigned the fairing a little bit. So let's change the date for Wonton. Yeah, so change the updated thing. There we go. All right, cool. Hey, who are you calling mature? Wait, what are my values? Is it full test time? Well, no. I gotta redo the stage. We had 1 ton payload capacity. This was perfect, but that's not perfect anymore. We could lengthen our upper stage if we really wanted to. What is that gonna do? Let's take a look. What happens if we? What happens if we do that? What's the delta V on the stage then? 4374. That, oh, I didn't put a payload up there. We gotta put a payload up there. What are we talking about? With 2250 kilo payload, we're looking at 2450 by extending the stage like this. Question, is there a scenario that if a payload wasn't heavy enough, that they would send up ballast? Is there a minimum load to send rockets into orbit? For some rockets, Nick Paw, yes, there's a minimum payload. For some, not for others. Now, what doesn't have a minimum payload capacity? The shuttle. You could put a piece of paper in the payload bay, or you could put a school bus in the payload bay. It'll fly the same way into space, no matter what. Think about that for a second. Think about how cool that actually is. Remember, the shuttle's payload bay is on the side of the vehicle. What do you mean? You could put a piece of paper in there or a school bus and it'll fly exactly the same? That's pretty cool. Pretty trick engineering right there. Some rockets do have a minimum component, but you got to remember, like, is that part of your expectations, right? So this is about letting your requirements drive your design, all right? Why would you launch nothing into space? And why would you, what's the scenario for launching nothing on your rocket? If that is needed for your vehicle's requirements, then yeah, that's something you're going to have to design around, right? But I'm pretty sure what would cause a rocket to require a minimum load? Bingo. What are you doing? There's almost no scenario, except for the shuttle, that you would bring up nothing. Why would you bring up nothing with the space shuttle? Well, if you're going to pick something up from space, then yeah, having it launch with an empty payload bay is huge. Or you're doing a Hubble servicing mission, in which case there's nothing in the payload bay except for the adapter and some space suits. Well, not space suits, the tools for the suits. See, it's all about design requirements. Why would you make a rocket that's designed to move nothing into space when you don't need a rocket that's going to put nothing into space? So, okay, another way to say it would be like, okay, say we do. Say we have a scenario where we want this thing to get into space with nothing on top. What would be your way around that? Well, your way around that would be to change something else, right? So you could beef up, for instance, these are just examples. This is not like the end all be all of what you could do. You could make the rocket stronger so it could move faster. It could withstand your compression loads, but that involves adding more mass. So you're losing payload capacity at that point. Not that you have any, right? Could do that. It's doable. You could make throttleable engines. You could work on your propulsion systems and make your propulsion systems throttleable. But your propulsion systems, often in rocket design, are what's called a long lead item. Rocket engines take a long time to design. They're complicated. That's the most complicated part of any rocket by a long shot, is the part that's called rocket. The engine is the motor is the most challenging component. That is the most complicated. So ideally, you would design those first. So if you're designing a vehicle from the start with the expectation that you need to move nothing or everything in that payload, right? You want a wide nominal range of payloads because say you're a commercial launch provider and you need to do that, right? I would start thinking about being able to make my propulsion throttleable. Throttleable propulsion is not something that every rocket motor has. The shuttle engines could only throttle to 66%, and that's it. They can throttle down to 66. You go below that, the engine starts to blow up because you're introducing really weird vibrations into things and it breaks it. Raptor engines are deep throttleable. So are Merlin engines. You can throttle them down to around 40%, both of them, which is insane to think about. SpaceX makes it look easy. The reason why they do that, having throttleable rocket engines is very useful when you're landing things. SpaceX likes to do that a lot. So it makes sense for them. Something like Atlas with an RD-180, I mean, RD-180s are throttleable, but only a little. They're not like deep throttleable, but it's good enough, right? Take like an F1 engine, for instance. F1 engines, they really have only two settings, on and off. Right? Not very throttleable. But that's what was needed to push the Saturn V into space. So, you know, is there a scenario for it, dude? I don't mean to answer your question with a question, but that would all really depend on what your vehicle's supposed to do. Right now, is there any reason to send a Falcon 9 up with just a payload fairing and nothing on board? The only conceivable scenario where I could see that being a thing is if they needed a second stage on orbit with a full tank of gas to push something somewhere. And SpaceX is not going to do that with Falcon 9. They're going to do that with Starship. Didn't the F1 engine development begin in the mid to late 50s thousands? Yeah. The F1 engine started as an ICBM propulsion system to move a bigger nuke. Yeah. That was the idea. Move a bigger nuke. Have one engine to move a gigantic nuclear warhead. And then we figured out how to make those things smaller and it wasn't really needed. So the application went from missile applications to NASA applications in the early 60s around the time of the Apollo program. Engineering. The art is the art of answering questions with more questions. Is it though? But I mean, if a client has a satellite that is light in mass, wouldn't that be an issue? Sure. Sure. But that's why most commercial vehicles, Nick Paw, nowadays have engines with throttle ability. RD-180s, they can't deep throttle, but they can throttle. To not break the vehicle, to not increase the maximum dynamic pressure. So much to the point where the structure of the vehicle can't take it. Shuttle did that. Falcon does that, but Falcon engines are super throttleable, and that's what makes Falcon so damn good, because it can do stuff like this. Falcon, because the engines have deep throttle ability built into them from the start, right, can carry a very wide range of payload masses and sizes into space. That's pretty smart, right? So you do see this in real life. The answer is throttleable engines. It always goes back to defense, doesn't it? Yeah. Well, Falcon doesn't. Falcon does not. Falcon does have lineage, and its lineage is not just Falcon 1, believe it or not. The Merlin engine is part of the family tree with something that comes from the golden age of NASA. Falcon 9 that's Falcon 9's grandfather right there. If you really want to know. Yep, that's right. Well, the golden part is not the ascent module, the LEM, the descent module on the LEM. Merlin engines are derived from the descent module. It's called the LMDE, the Lunar Module Descent Engine. Falcon 9's, that's Falcon 9's grandpa. Not a lot of people know that. Yep. Why is it Falcon 9's grandfather, you ask? Well, a lot of people at SpaceX were answering the question, well, how the heck do we land a rocket vertically? 15 years ago. How the heck are we going to land one of these things vertically? How are we going to do that? We want to reuse the vehicle eventually, but if we land it vertically, we're going to need a highly throttleable engine to be able to take into account the minor changes needed. Have rockets ever landed vertically in the past? Yes, they have. There's a good example of one. Landing legs and everything. So Tom Mueller, SpaceX's chief propulsion engineer at the time, looked to the LMDE and said, "Oh crap, we should do that. We should do that, but with kerosene and liquid oxygen, because kerosene and liquid oxygen is cheaper than using hypergalls. That's pressure-fed hypergalls, which we already learned about this stream. So the injection mechanism, the fuel injector plate, and the combustion chamber mechanism from the LMDE, SpaceX lifted that for Falcon 9. I mean, it was a clean sheet design, but it was inspired by that. Fun fact. Not a lot of people know that. Yeah. Falcon 9's grandfather is the LEM. Pretty cool, huh? They were cooking in the 50s and the 60s with spaceflight, dude. With rockets, man. So many good ideas not underutilized, dude. So many good ideas. It's ridiculous. All right. So we were into analysis. Let's take that off. Get rid of that. So with this, our delta V numbers, change of velocity numbers are reading 1525 with 2.25 tons of payload. The wonton design, before we redefined our expectations here, the wonton design was 1100 and it had 2200 meters a second delta V with 1100 kilograms of payload. Now we have 2250 kilos with the same upper stage. We've lost about 700 meters a second delta V. So let's see where this gets us, just out of curiosity. So that's 2034. Not bad. Not bad. That's okay. I don't like it. You don't like it? No, I don't like it. I think I'm going to keep that like that. So, let's look at requirement. Oh God, let's look at requirements again. In order to get into an 80-kilometer circular orbit, you need 3,400 meters a second delta V. Our second stage, change in velocity. Our second stage has 1525. So if we keep it like that, because it's simple, I like that because it's simplified. It's it's not complicated, right? Even though the trade-off there is that, we could make it more parts, we could add delta V with it, but I'm thinking a rocket, that makes wonton's length really long, and a longer rocket is going to be harder to integrate. It's going to be harder to erect it. All right, so 3,400 minus 1525 means we need a stage that makes... That means we need a stage that has 1875 delta V. Music is too quiet. I can almost hear you talking. Hey, EJ. Hey, what's up, JV? Or JZ? Oh, the music is too loud. Do you think you could turn it down a bit? I'm having trouble hearing. Yeah, dude, I'll get right on that. You see, JZ, that's how humans converse with each other. Yeah, here, let me get on that. Let me turn it down for you. There you go. Am I getting this right? The bigger the fuel tank, the more delta V. Yes and no, Pigeon. In this particular application, yes. But delta V, the delta V formula, a component to the delta V formula uses a natural logarithmic scale, which means it doesn't scale linearly. Just because you doubled the size of the fuel tank does not necessarily mean you're going to double your delta V.
Discovery, go and throttle up.
60-month resub. Worm. Thank you for your time. I've learned so much over the years. My pleasure. Thank you for watching. I turned it back up just a little bit, dudes. I didn't mean it like that. Oh. Never mind then. It's good, Vargon, yeah. I redesigned it and I changed a couple of requirements for Wonton to the point where the Wonton name doesn't really make sense anymore. I switched it to 2-ton launch capacity because I was looking at my other small sat launcher that I made for mission mode. I was looking at Imahara and I realized that that rocket is really more well suited for small sat launching, and in doing that we changed the payload capacity. So the Wonton rocket is really the 2-tron rocket now. 2-ton rocket, 2-ton, so 2-ton, yeah. Pretty much, but I don't feel like making another craft file in here, so we'll just keep calling it Wonton for now. It's basically Imahara 2.0, but it's scratch built. So really, scratch building a rocket that's based off of another rocket is not really grounds for calling it 2.0. But yeah, extra spicy wonton. Yeah, we could add SRBs. I saw some of you guys talking about it. We could add SRBs, but remember, whatever we add, we have to integrate potentially. Call it one wonton. Oh dear. Hang on. I'm gonna move the thrusters in just a little bit. Yeah, there we go. Cool. Once your mission mode gets started, will you start out with a small sat? Vargon, so what I did with mission mode the last time I played it was I didn't scratch build a vehicle when the save started. What I did was I built a small sat launcher, a minimum viable small sat launcher, and started mission mode with that launcher. I started with one. So when we start mission mode, I wouldn't just be sitting here doing this all day. You'd actually get some launches. So if we do, what I'm trying to tell you is that when we do start another mission mode, Wonton will, or Neutron or whatever you want to call it. Maybe we should just call it like Fred or something. I don't know, dude. We've called stuff in my space programs Fred before, and Jeff, just because I couldn't come up with the names. It's like, I don't know what we should call it. Maybe we should call it Greg. Maybe. Vote on it. Hell no. No way. Why are we building a rocket in the hangar bay? Fox, I like building rockets in here because you have better camera controls. Do you see how I'm moving the camera around? Much easier to build.
What's an astronaut's favorite computer key? The space bar.
Scooter. Stop that. Yeah, I know, right, CM? Get that guy. Get that guy. All right. Give me 1 second, dudes. I got a message. Might be important. Don't forget dinner. Yeah. Okay. Let's build the stage here. So, all right. Another thing that I don't like doing, guys, is so if we want to go and attach this thing here, it's giving me the option to attach it to the rocket engine. Rocket engines are not structural. They are not structural. The things they're attached to are, right? So I don't really like this. I think this makes for a very weeble wobbly rocket, and I'm not really a big fan of that. Even with the shroud and everything. It does look nice, but I don't like doing that. Here's a little bit of a trick that you can do with this. So, when a wonton is not big enough, have dim sum. Oh, dim sum. Could use some pork dumplings, dude. Sorry, talking to Sawyer. All right. So, let's tool around with this. I don't want to attach to a rocket engine. So how do we, okay, how do we do that? Well, here's a trick that you can do. Nose cones, right? Let's find the smallest nose cone that we possibly can, right? And what I'm gonna do, nose cones can be radially attached. See? Right? I'm gonna attach my rocket engine to the nose cone. And what I'm going to do now is take a decoupler, right? And I'm going to attach a decoupler to the tank instead. We're going to move that back, right? And here, we can do some pretty cool stuff here, right? the nose cone, right? The downside of this is that Kerbal thinks this is attached on the side now, even if I move it down into position. But bear with me here. Now our decoupler is attached to the fuel tank. Remember, in real life, rocket engines are not structural. The things they're attached to are, like a thrust structure on a first stage, or a bulkhead or an aft dome design on the second stage, right? I'd like taking the rockets out of the mainline structure. I think that makes for a more structurally rigid rocket. It makes it less weeble wobbly, right? And I frankly think it looks cooler. Go figure. Now, another thing we're gonna do here, let me think about this for a second. We could use the small nose cone, or let's see, what else do we got in here? What other nose cones we got? We got that one. That's too small. We got this. That's not radially attachable. That is. Why do engine plates not work in this situation? Engine plates suck. Yeah, that's why they don't work in this situation. They force auto strut on things, Muffin. They force auto strut on things, and they generally have really just unpredictable behavior. Not a fan. How about this nacelle here? The fan shroud. We could use that. Let's get rid of that. Right? Let's attach the engine to that. Now, the cool thing is that we can really, make this look neato burrito by doing something like that. Oh. Right? Yeah, look at that. That looks pretty good. And, hold up. Do we have a 1.8 thruster? No. Nah, it really doesn't want to be that way. So we'll use this, and we'll, the cool thing here is that looks like your turbine machinery. It looks like the rocket engine. And I really like that the 909, the Terrier engine, has just these two things on the side, and it just has a nozzle. There's no throat, there's no combustion chamber. I always thought that was a little bit strange. So what we're gonna do, because fan shrouds don't really cost anything, there's $85, 85 flurbos. Let's put that in there, and now that looks right. What I was trying to do is find something that we could potentially make taper out so it looks like the thrusters are in the right spots, but I don't mind the thrusters floating there either. It also gives us a little bit of room for the balls. Why the nacelle and not, say, a cubic octagonal strut? Oh, because it looks better, and it's inexpensive. I mean, the cubic octag, I think, is probably the least expensive, but that don't look right. With this, you don't know what's behind there. It might be, there could be rocket turbine machinery back there. You don't know. Now look at that. Now that looks like a second stage. It looks good. All right. So now we have our decoupler down here. And now, here's the thing. Kerbal doesn't understand that this is behind the tank because I attached it on the side. So Kerbal is treating it aerodynamically like it's attached to the side. That's no good. That's not good. Nobody wants that. That's bad. We don't want that, right? Because that means the engine will be making drag when the rocket's going up, and you don't want drag being made high up on the vehicle when you're trying to fly through the atmosphere. This is the reason why rockets have nacelles, have like fins and nacelles and stuff at the bottom, right? They have them down there to lower your center of pressure because they're making drag intentionally at the back of the rocket, right? Now, with all that being said, how are we going to tell KSP? How are we going to tell Kerbal that rocket shouldn't be aerodynamically there? Well, a fairing is a good way to tell Kerbin that thing shouldn't be subjected to aerodynamics. So instead of doing this dang shroud thing with the rocket engine, I don't like that. What I'm going to do is I'm going to take another one of these small nose cones, right? And I'm going to attach it to the back of the rocket engine first. I attached it to the back of the rocket engine so I know that I don't accidentally attach it to anything else. And we know we attached it because of the shroud. I'm just going to take that nose cone for a second and just move it out of the way. Now what do we do? Well, all right. Here's where we kind of hit a little bit of a convergent divergent path with our rocket engine design, right? Some people have asked me, will we try to reuse Wonton's first stage? I don't know. Do you guys want to? Do you guys want to? Hey, Redbeard, just got back from class. How's it going? Is this the start of the new mission mode, you think? It's the start of a new rocket that could be used for mission mode, Redbeard. What's up with the light coming from the hangar? I don't know. Don't look in the light. EJ, you're in Boston, right? Yeah, some stuff is happening now in downtown. Please stay safe. I'm not in the city. I moved out of the city. The reason why I moved out of the city, Blake, is for reasons like this. Nah, keep it simple at first? Okay. Maybe, SpaceX didn't design reusability into their vehicle, into Falcon 9 first. They didn't design that, right? But Falcon 9 eventually became reusable. So, let's think about this for a second. Maybe we do want to make this reusable eventually. You know, do the whole Falcon 9 boost back and land. But, dude, we haven't even launched this thing. We haven't even finished doing the analysis. I'm not going to design a reusable system right now. In my mission mode saves use career mode, so cost is very, very important. Okay, so let's think about this for a second. What are the things that we will absolutely need if we ever got one of these boosters back? Things that we need to also make the vehicle work. I'll give you, a little bit of a hint. A rocket engine is one of those. We need that. We need that for the expendable and the reusable version. That's important. Fuel tanks, obviously. Right? You need that. That's, yeah, you need those. Right? What else? We're going to build a fairing here, right? Remember I said we need to aerodynamically tell Kerbal that this is not hanging off the side. Best way to do that is a fairing. So how about we make an inner stage out of a fairing? How about we do that? All right, cool. So if we do that, let's back it off a little bit, give ourselves some breathing room, right? And let's build ourselves a fairing. Oh, the engine collider. Look, see how the engine is highlighting? It won't let me build the fairing that far. Because it thinks it's the shroud. The shroud is collidable. All right, how do we get around this one? We got a little bit of a pickle. When was the last time we pushed the outer system in mission mode? Never. It would be cool to get back there, in your opinion. Never did it. so I'll tell you guys what, because in the spirit of time, it's 5 o'clock already. We have the new Centaur Lima launch happening at 8. The weather is not looking great for it to fly at 8. There's a viewer in my chat named Nate. And you stay out of my way. You listen to what I say. And then make things out of clay and lay by the bay. Just may. What do you say? Anyway, I don't even know what I was talking about, dude. I'm usually better at staying focused. Anyway, I mean, I'm not, but you get the idea. So I'm gonna leave some room right here with the fairing. I'm gonna leave room right there because my first stage, if we're gonna eventually try to want to reuse one of these things at some point, right? We need an engine, we need a fuel tank, but you need a probe core. So what I am going to do is I'm basically going to lift my avionics package and just put it right there. We don't necessarily need to do that, right? If the initial versions of this are expendable, the first stage can be dumb. It's not a big deal. It doesn't need probe core and batteries, but eventually it might. So when we go to make our interstage design here, we're going to make it a little bit longer than it needs to be to take into account that maybe someday when we go to reuse this stage, we can put a probe core here, right? We want to put a probe core there. So what I'm going to do is just take this and we're going to turn on the fairing interstage nodes again. I'm going to rotate this up like that. And we'll put it there, rotate this back into position. I rotated it out of the way to make sure that to ensure that it attaches to the fairing. Oh, look at that, dude. It's perfect. Have a little bit of clearance there just in case. But yeah. Now, the other thing I'm kind of wondering about is with Imahara, how did our staging go? So what I'm going to do, we're just going to attach that there. We're going to leave this just like this. No, not build this just yet. I'm wondering, can we make a fairing, an interstage, go around that rocket motor, and will it cause a collision problem with the fairing? I don't know. Let's go look. Let's go look at the vehicle again. Yeah, I don't know, dudes. I don't know. Can you rebuild fairings in EVA construction? I don't think so, but I've never tried, Jackal. I think it would be cool if we went with a neutron type design. How? You don't have this in stock KSP. You don't have a chomper fairing. The closest thing would be that. We could deploy it out the cargo ramp and use that as our chomper. But it would be weird flying a duckbill platypus into space every time, Blackness, don't you think? Looks like a baby Falcon 9. Yeah. I'm not sure how that's gonna work, guys. Perhaps my extension isn't a good idea. So a couple of things that we could do. The reason I think this is gonna work is because the fairing basically ends where the rocket collision ends. So that might be a little bit of a wonky separation with Imahara. I don't remember that being a problem, but I know that if we have it go past it, we're gonna have some problems. So let's think about this for a second. Go back to Wonton here. Are there any other options here for upper stage engines that we might want to look at? Let's take a look. Remember, so, okay, who was paying attention in part 1? What are we looking for an upper stage engine? What are you looking for? What's the big one? Wizard, you just successfully got a transmission to connect and go into a torque converter without little hassle, actually. Nice. That's what you're saying. Racing stripes. I mean, yeah, well, of course. Sorry, but yes. Ryan, you got it over there in the YouTube chat. Ah, YouTube chat beat you, Twitch chat. Ryan over there in the YouTube chat said specific impulse before you did, Blackness. Oof. Oof. Oof, you guys are getting shown up. We're looking for good vacuum specific impulse. Just to reiterate, I went into detail about what specific impulse means in part 1. But just to reiterate, specific impulse is your efficiency. How efficiently can your rocket burn propellants and shoot it out the back? That's it. The number is measured in burn time seconds, and the higher the number, the more efficient it is. The higher a specific impulse of a rocket engine is like having a car with higher miles per gallon. Oh, good for you. So, the Terrier engine, which is tax exemption, right there. It's 500 kilos, 345 second specific impulse in vacuum at 60 kilonewtons of thrust. All right, is there anything even remotely close to that? The Rhino makes 340 second specific impulse, but the Rhino might be a little too big for our application here, considering that the engine is bigger than my second stage and payload fairing. Probably don't want to do that. The swivel engine, 320 at 215. That's really, really high thrust to weight ratio. It's not as efficient, but it makes way more thrust. We don't necessarily need more thrust, but that is the engine I'm using for the first stage. It could be useful. And its gliders aren't screwed up at all, either. The gliders aren't messed up. In case you wanted to have Fleet's race on another screen, about 30 minutes till green. Oh, okay. Now, there's a lot of smaller engines in KSP here. The Spider is 290. That's not good. 315 on the Ant engine. What about the Spark engine? Spark makes 20 kilonewtons of thrust at 320 seconds specific impulse, and it's 130 kilos. That's not bad. Spark could be a contender. What else? Other things there's a Cub engine that makes 310 at 32. Higher thrust, lower specific impulse. Not exactly what we're looking for here. Wolfhound is amazing. It makes great... It's one of the most efficient engines in the game. 380 second specific impulse at 375. That's a little bit large for our application. What about a Skiff? Skiff makes 300 at 330. That's a pretty decent upper stage engine, but also it's as big as the second stage. Probably not what we're looking for exactly. 2 Sparks, Muffin? That'll give us 40 kilonewtons of thrust at 320. You had to watch 2 ads to get here? Jack is mapping. Do you want to watch 3 to get here? I can make that happen. Otherwise, that's out of my control, dude. The only thing that's in my control is I can get you to watch more ads. Pretty sure you don't want that. second B-21 Raiders flown. Hell nah, ain't worth it. Thanks. Twin Sparks is not a bad idea, Muffin. I don't mind that. But that's not going to give us the efficiency that we're looking for. I'm kind of thinking maybe try this with the stage and then hope and pray that the engine doesn't get hung up. Oh, there is another thing that we need to do here. So if we're going to do this, we need to make a docking port. We need to put a docking port in the decoupling system here. The reason why we needed to do that is because if we ever reuse this, right, this mechanism is going to be needed to reintegrate a stage. You need a docking port to be able to reattach something to the stage. Decouplers don't have reattachment capability. And the back part of that is not glidable, so there you go. Could an SRB be used for stage 2? Solids in this game generally aren't really good up there. 195 vacuum, 165 vacuum for any engine that would be suited for application here. 210 vac, 215, they kind of suck, dude. SRBs in this game are really not vacuum optimized. They're very much first stage and attachable SRB mechanisms. Let's just try to make it. So here's what I'm gonna do. In order to do this, I'm gonna have to make the inner stage not like I can't just build it because see how the engine's highlighting? It's gonna get in the way. So there's a trick. There's a trick that we can do here. I'm gonna make one of my rulers again, the Tessa ruler. Right? We're gonna pull the ruler this way by holding left shift, and then we're gonna move it this way. Note that I attached it to the fairing, okay? So what we need to do is push this ruler into a position where we want our fairing to end, right? So where does the glider on the tank end? It ends pretty much right where the checkerboard where the checkerboard starts. Right, so I'm gonna just dial this in so the edge of the strut is right where the glider starts. And just to be sure, let's, move this out of the way, right? Now, we attached that to the fairing. So if we take the fairing, right, and we move it all the way back, move it out of the way, now we have the exact length to that tank. So we build out our fairing, right? And then we just, the second it starts gliding with the strut, just, get a close eye on it. Right? We can hit left alt, left mouse button, and terminate the fairing. And then now we have an open fairing. So now we take the fairing, we move it back into position, we make sure that it lines up with the ruler, and boom. Inner stage. See? Pretty cool, huh? And now, remember, the way I attached the Terrier engine, guys, the way we attached it, I attached it on the side, right? So Kerbal thinks it's on the side. Kerbal thinks it's attached on the side. Kerbal thinks that's in the way of aerodynamic flow. It doesn't understand that it's behind the tank. Kerbal isn't that good. But now it does because it's inside of a fairing. Fairings occlude stuff. Anything that's inside of it gets occluded. The game, Kerbal now knows that everything that we put in here is not hanging off the side of the vehicle. And now you have an interstage, a reusable interstage. So we can get rid of that nose cone. We don't need that anymore. There you go. We can go in here like this, get rid of that. Now let's just do some auto strutting in here. And now we've put in the provisions because we put a docking port on the top of our second stage attached to a decoupler, right? We put the provisions in to make this reusable if we ever need to. We just got to make sure that this thing can actually separate correctly without causing a huge problem with the bearing. We'll have to test that, but we'll test it later. See? Reusable interstage. It'll stay with the first stage, so if we ever want to get our first stage back, boom. Simultaneously, we ever want to put on, say we do get our first stage back, we're going to need to attach a second stage to it at some point, right? You have to do that. You can't, what's the point of getting the first stage back if you can't attach something to it, right? If we want to reuse the dang thing. Now, because I have a decoupler with a docking port, I can reattach a new payload fairing and new second stage to this. Perfectly reintegratable. I've used this system before on other rockets. It absolutely works. I've reused first stages from rockets in mission mode. I've had them come back down. I have a vehicle that goes, grabs them, picks them up, takes them back over to the pad, puts them on the pad, puts a new stage and a new payload fairing on top, and you're good to go. Yeah, sure, Baron. What was the Delta V needed for stage 1 again? Well, give me 1 second. I have to remove some of this stuff around. We have to disable staging on that. And we have to move our second stage engine there. 1511 on the second stage. So we need 3,400 total. So that means we need 1,800 on the second stage. Guys, I would round that number up to 2,000. Multiple reasons. I would round it up to 2,000 because, once again, think about long term. We're not reusing this stage right now. But if we do reuse this stage, if we do want to reuse this stage, we're going to want that extra performance. You're going to want the extra fuel. In the meantime, we can use that extra fuel to boost our payloads further, right? But you're going to want to add a little bit of margin in on your second stage, right? We need 1,800. I'm going to figure 2 kilometers a second. I'm going to figure 2,000, right? That gives us an extra 111 meters a second delta V on the first stage. That's a lot of extra burn time, right? That's a little bit over engineered, right? But that's going to work. We know that's going to work. It'll absolutely help us hit our goal of getting, it was 1 ton, but now it's 2 tons into space. And it should theoretically help us to, if we want to fly not with 2 tons, if we want to fly with 1 ton and go for reuse, we can absolutely do that. Because we built extensions into the first stage to start. We figured way more than what we need. I'll give you another hint of a family of rockets that have done this. Look at Falcon 1, then look at Falcon 9. And then look, Falcon 9 1.0 to 1.1. They did the same thing. SpaceX did the same thing. That's where I got the idea. SpaceX is a pretty good thing to want to emulate, in my opinion. This is from historicspacecraft.com. Actually, a pretty damn good infographic. Cool. Here, I'll link this stuff up if you guys want to see it. Go and support cool sites like this that make cool infographics. The wonton is now a lie? It's not a lie. Vehicles' names change all the time. So let's figure 2000 into our stage here. Where is 2 of these tanks going to get us? Oh.
Discovery, go at throttle up.
But I wanted the spicy wonton variant. This is the spicy wonton variant. Sawyer, tier 2, 94-month resub. Thank you. $16.35. Oh boy, we're about 400 Delta V short. What about the cuttlefish and asparagus? TWR? 1.0 fudge. Our avionics jackas, our avionics have short band capability. This rocket isn't going to go very far, so I wouldn't worry about that too much. We might need communications antennas for it eventually, but would you maybe use a different engine for the first stage? Here you go. Oh, interesting, dude. What the heck is this, Baron? Project MPKVP. Known as Glishko's opening gambit. Russian manned spaceplane, 1974 study. Competitor with Buran. Manned lifting body spaceplane designed by Soviet engineers as a recoverable spacecraft in the 1970s. What? No. Oh. Mom, can we have space shuttle? No, we have space shuttle at home. Space shuttle at home. Reusable transport spacecraft vertical landing. Oh, what the? Payload 80 tons? Who folded the drawings? I don't know, man. It's it launches as a tri-core with this thing being oh my god. Look, there's 3 boosters behind this thing and a fuel tank. What the hell is Glushko thinking? What are you, nuts? How the hell is this gonna work, dude? Found your inspiration for new dart? That is kind of what we were thinking, isn't it, dude? Nah, I'm good. I ain't making that. That's, yeah, nah, yeah, nah, mate, yeah, nah. It got a pretty big payload bay, though. Yeah, no, nah, I'm good, mate. So sea level, we're at 1.04. $1635 meters a second delta V. Yeah, Archie, the space plane looks cool. Can't say the same thing about the second one. Jacques, what are you linking? Yeah. So we have a single LVT-45 swivel up in this thing. It makes 167 kilonewtons of thrust at 320 seconds vacuum. That's 250 at sea level. Can I look at something? So I wish you would do stupid spacecraft idea episodes in KSP. It would be hilarious. Aren't those just car streams? 27 engines would theoretically give the same thrust as 3 big ones. Image for reference. You just linked a picture of Falcon Heavy, and it's an old version. It's a version of Falcon Heavy that never flew. I'm not sure what you're trying to tell me here, Jaka. Guys, I smell something burning again. It smells like fire. Let me just make sure my neighbors have a fire going in their backyard and the shop isn't burning down. I'll be right back, 1 second, okay? not burning down, so that's good. Not stationeersing ourselves, so that's a good time. So spark engines would be cool because we get 9 engines, and I think that'd be super neat, but they really don't make the thrust that we're gonna need. We have more delta V because of the higher specific impulse, but we don't really have the TWR. If these things made 20 kilonewtons at sea level, that'd be pretty good. Neighbor burning trash? No, my neighbors get gets a fire going. That's what they like doing over there. But the other thing is that we still don't have the delta V that we need. 1700. It's close. This could probably get 2 tons into space, not 2200. 2 tons. 22. It could probably get 2 tons into space, not 2.2. This is actually a pretty capable little vehicle. And this could absolutely get 1 ton into space reusable. So we could, keep calling it 1 ton. 2 thuds? 2 thuds were what we did in the past, man. Thuds are actually pretty good first stage engines, and I remember we had this exact conversation. Now, the thuds are all fine and dandy. The 9 spark design, like Electron style here, that would allow us to land this a lot easier because we have better throttle control having a bunch of small engines instead of having one big one trying to throttle it. Do rockets get their angles of attitude, or do they use gyros or horizon-based systems, or what? Inertial measuring units. Blackness, that's where I was going with it. That's where I was going with that. We could make... Dude, we could use a Cal controller, and we could get a little more kick out of these engines, and that would give us what we need, but it wouldn't give us the delta V that we need. So we might need to change this a little bit more. What about Cubs? Cubs make 1,800 meters a second at 160. 1.6 TWR. That's too much. I mean, that is kind of sick though, but that's a little too much. Seven Cubs? .27, 1870. We're approaching. Does it have to be 9? No. Do a double center engine design like what ABL designed for RS1. I mean, I kind of like what's on the screen right there. 1.27 at 1.8. 6? We're doing an Astra? Are we doing an Astra here? Oh no. .1 at 1900. The grav loss is no good. I don't like that. The thing about Cub engines, guys, the other thing is that they can only gimbal in one direction. This thing, see the hinge right there? It can only do this. It can't do that. Because these are they're designed to be vernier engines that you attach to the side. ABL's early design had 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 around the exterior. Don't worry, I'll do something about the Z fighting Testamax. It's all good. Now, we have yaw, pitch, and roll. We don't, these motors up here, they don't even need to be, they don't need to have thrust vector control. It's just that one, and that one. What's our thrust vector control range, and what's the mass of one of these motors? 180 kilos, and our vector control range is 22 degrees. That's way overkill for what we're doing here. Will be preferable if we ever try to land this thing, though. One mastodon in the middle. Nah. Let me see something crazy here. I like the smaller engines. I think that's a cool idea. What does that do? 1718 at 1.4. It's too much. We need a little less mass, a little more efficiency. A different engine for the center. I hate it. I'm not doing that. I hate it. It is an irrational hatred of different types of engines. I'm not. Hell no. No. I'm vetoing that. I don't. Yes, that would probably be a good idea, Oculus. I'm not doing it. Okay. I'm not doing it. Don't even try to unpack that one. Okay. We're not doing that. Yeah, we're not doing that. We're not doing. What are you kidding? No, we're not doing that. I am immediately vetoing that. Oh, I got a great idea. Nah, I'm just kidding. I'm kidding. I'm not doing that. I'm just kidding. If you know, you know. We're not doing that. We're not doing that. You do it, you won't? Yeah, that's right. I won't. yeah, that's right. It goes in the square hole. It goes, no, we're not doing that. Guys, I got a plan. Just add more engines to the outside. My God, what a genius. What about a Reliant as the center and 2 or 4 Torch engines for steering? Are you doing this on purpose? These are spark engines. I like that. And I like that. And I like it with Cal overclocking. If we just make these engines have a little bit more staminky, these things should go. Last. I'm trying to finish this, man. What the hell do you want? I swear this is why you ended up on with thuds on Imahara. Yeah. I want to talk to Sam. This is Samson, smart bit. Samson is a Sheila Mama Phil. Shut up, chat. You tell Mr. Nice Guy to get his Jamaican ass down here. You hear me? Kenta, what's this? Oh my god. It's so small. Tim, it's so small. It's small. It's a little small guy. Look at it, Chad. This is tiny. Tim! Fellas, it's not a bad idea. That's not a bad idea, dude. Ain't a bad idea. Make Starship, make HLS sized application. Enough to get people there, and that's it. People and their life support systems there, and that's it. Much smaller design, less refueling, cut down. That's actually a pretty smart idea, dude. I actually don't hate it. It's a little strange looking, but I don't hate it. How does he intend human landing system TLI? We can talk more about it and take a look at it when we're finished. Get off the screen. When we're finished designing. Now, guys, the thing is that we're going to have to get into analysis here, because if we overclock these engines, so I can make these engines produce just a little bit more thrust. We go here and I select them and go to thrust limiter and thrust limiter, and we take the curve, right, which is like 0 to 100, and we just bend the curve off the screen a little bit, place it there. Now they're making 1.5 times the amount, or 150% of their rated performance. We don't necessarily need 150%. Let's just chip that down to like right there. 116. That's good. Take that, copy that, paste that, paste. Take this, copy that, paste it there so all the engines have it. Move this around. Now look. Check that out. We made the line go off the screen. Look at the thrust limiters. 116.8. Now go over here and just try to refactor this a little bit. Not giving us the proper thrust to weight here. Spark engines at sea level make they make a fraction of their No. Chap, my brain's paced. How do you find how much percentage that is? What is it, like 80%? Yeah, RS-25 style. It's not unfounded blackness, which is why I don't mind doing it. Because, see, overclocking rockets make your Delta V readout over there go bananas. It's not right. It doesn't understand what you're doing. Okay, so these engines are making 116.8. $116.9. So let's say 117. Good number. 117% of rated performance on the Spark engines. That TWR, it's not 0.94 anymore. So what is this going to make? And then we're going to have to do the Delta V formula out for it by itself, which... yeah. We'd have to do the Delta V out manually, but that's fine. That's okay. We've done that. We did that in our analysis. Let's... yeah, there you go, X-Wing, right? One 1.2. So headcanon is that these engines reliably tested higher than rated thrust. Otherwise, going above 100% is an in-universe dangerous. Yeah. Well, you can always test the engine more. A lot of engines have their thrust rating past their initial baseline rating of 100%. Shuttle engines, for instance, could go to 109. SLS engines can go to 113, and it's using shuttle engines. Well, all right, guys, it's almost 6 o'clock. So I'm gonna go grab some dinner, and then we'll come back and do space news. So we got through some good analysis here on Wonton here. Wonton is gonna end up being a 1-ton reusable rocket, from what I can tell. 1 ton to orbit with full reuse is what I'm looking at here with these numbers. We're gonna need to do first stage analysis with overclock, TWR and DB. That's what we're gonna have to do next time. Respectfully, hell yeah. This 9-engine variant is going to be super cool. That's going to be a cool little rocket. I have some ideas for how we can make the thrust structure look really good and be really primed for reuse. It's going to be nice. So, yeah. So, I'm going to go... I'm going to take a break, guys. I'll be back in a little bit for space news. We're going to start space news a little later than usual. And we're going to go all the way to the new Centaur Lima launch, which is at 8. That's in 2 hours and 10 minutes from... 2 hours and 10 minutes from now. Yeah. Fellas, I'm not... if you're wondering what we're going to do for after hours, I'm not doing after hours tonight. I'm not really having the best of days. It's a little bit tough to focus today. So yeah, I'm gonna take a breather, but don't worry, we're still gonna do space news. I'm here. I'm just having trouble going rockets. All right, so I'll be back in a little bit for space news. You guys know the drill. I'm gonna jog the YouTube VOD. We're gonna shut it off for a second. On Twitch, just stay here. I'll be back. We'll do our segment on space news. So hopefully you learned something here about rockets. That's gonna do it for part 2 of this build, where we've already redefined stakeholder expectations twice. But that's fine. It's fine. Now's the time to do it. We'll figure out more about building a launch complex and pad out in a moment. I mean, I don't know about you guys. I kind of want to do this tomorrow, if you don't mind. We'll do it before Flame Trench. We'll try to get the design of this vehicle all ready to go. That's right. 3 days of Kerbal this week. How about that, huh? How about that? What's for dinner? I don't know. I think Brimo said chicken. Are you you're doing the Falcon 1.9 engine, or Falcon 9 1.0 engine grid? I know how much you love that. No, I hate it. I hate it a lot. We're not doing that. I'll be back. I'll see you for part 3. If you're on Twitch, Space News is happening very soon. I'll be right back.